Now, I'd like to start the session H. The topic is session is mobility, automobile, and auto-guided vehicle. In particular, we would like to introduce the research and issue that each organization is conducting on the safety of interactions between human and mobilities. The target human here are sometimes the driver, sometimes pedestrian on the outside of mobile vehicle, and sometimes some workers on AGV in the factory. Other introductions to a wide range of safety activities related to automobiles also included. Now, I'd like to begin the presentation. Okay, please. Are you ready? So, Hiruka-san.
Okay.
Okay. The first speaker will be Hiruka-san from AIST. The title is Safety of Mobile Vehicle Among Automobile and Robots. Please start your presentation.
Can you see my slide? Okay.
Okay, I see. I can see.
Thank you, Chairman, for the introduction. Title of my talk is Safety of Mobile Vehicle Among Automobile and Robot. My name is Hirohisa Hirukawa from AIC Japan. This slide shows an outline of my talk. I introduce the type of mobile vehicle at first. The type range from automobile to indoor robot. Then I talk about safety laws and international standard for autonomous robot mobile vehicle, including traffic laws and ISO standard. I conclude my talk with some perspectives. This slide shows the type of mobile vehicles. The first type is automobile that run on a public road with a high speed. Safety of the automobile is regulated by traffic law and should have type approval from a government. The second type is a middle speed vehicle that run on public road under 20 km per hour. Safety of the middle speed vehicle is regulated mainly by traffic law and should have the type approval. Third type is low speed vehicle that on the public road under 6 km per hour, and it is considered as a pedestrian equivalent in Japan. Safety of low-speed vehicle is regulated mainly by safety standard with a guideline provided by a vehicle manufacturers group in Japan. Vehicle should have an arbitrary type certification instead of forced type approval. Last type is indoor vehicle that run inside a building with a low speed. Safety of the indoor vehicle is regulated by ISO 13482 as a personal care robot and ISO 36914 as an industrial truck. This slide shows an organization that discusses the safety regulation of automatic driving automobiles. The top of the organization is World Forum for Harmonization of Vehicle Regulation, or WB29, and 6 working parties belong to the forum. The working party for automated, autonomous, and connected vehicle is responsible for the automatic driving and discuss driver assistance and active safety function, validation method, cybersecurity, event data recorder, and functional requirement. In the working parties, automatic parking and steering for keeping and changing the driving lane have been discussed as automatic driving level 2 and 3, as well as a driver monitoring system. The picture shows an example of a certified automatic driven vehicle at level 3. I skip the middle skip vehicle because its safety is regulated by the mixture of traffic law for automobile and international standard for robot. The low-speed vehicle consists of person carriers and mobile servant for delivery. It is considered a pedestrian equivalent when the safety regulations are examined in Japan. The robot in this type can run on the pedestrian and roadways as well. Various experiments of the vehicle have been done on public road. This slide shows the major hazard of the low-speed vehicles. Hazards include a traffic accident, that means a robot is hit by an automobile on the roadway, a collision with a pedestrian or an obstacle, and falling at the rough terrain, such as a large step, steep slope, or stairs. ISO 13482 is a related safety standard for the person carrier, and it does not assume that the carrier run on a public road. For example, the traffic accident is not considered as a hazard. More risk assessment should be required to cope with the hazard. This slide shows an example of functional safety to prevent a traffic accident. Before the vehicle runs on a pedestrian crossing, it can be stopped reliably at a red signal when the vehicle can receive the signal information via sound wireless communication. The vehicle can avoid the collision with an automobile on the roadway when it can recognize the distance and speed of an approaching automobile. Millimeter wave radar is a promising candidate to implement the function, but we are not sure if it can be reliably now for the purpose at present. The performance of the radar is expected to be improved for automatic driving of automobile in the near future. This slide shows an example of functional safety to prevent the collision between a pedestrian and the vehicle and falling down of the vehicle at the rough terrain, including a large step, steep slope, and stairs. Fatal accident caused by the falling down of wheelchairs with steering without automatic driving function have happened at an equivalent rate as fatal traffic accident in these years in Japan. The collision between a pedestrian and the vehicle can be prevented by finding an approaching pedestrian or obstacle using a horizontally scanned 2D LiDAR. Its performance level should likely to be D, which depends on the risk assessment for a use case. The falling of the vehicle can be avoided by finding the rough terrain using a vertically scanned 2D LiDAR. Its performance level may be D or E, depending on the use case. Alarm using light and sound may help a pedestrian to notice the vehicle. The low-speed vehicle assumes automatic driving at level 3 instead of 4, in which the driver locates in a remote place. The driver works as an auditor of the automatic driving and overtaking the driving when the vehicle is out of an operating design domain. Safety functions for the teleoperations are when a communication disconnection is detected, stopping the vehicle on a pedestrian or moving it to be the right side on the roadway. When a vehicle is out of the operation design domain, assigning an auditor immediately to each vehicle when N vehicles are operated, and at last, monitoring the attention and operation of the auditors by checking vital signs, for example. This slide shows the example of mobile servant and person carriers moving at indoor environment. Traffic laws are not applied to the operation of the vehicle, and an Industrial Safety and Health Act should regulate their safety when they move at an industrial plant. Many mobile robots have been used for serving food at restaurants in these days due to the pandemic of the COVID-19, and autonomous wheelchairs are utilized to help passengers with reduced mobility at several airports. Major hazards of the indoor vehicle include a collision with a pedestrian and falling at the stairs. A large step and steep slopes should be excluded in the environment. Safety guidelines of industrial truck in Japan limit the maximum speed of the vehicle under 60 meters per minute. The collision between a pedestrian and the vehicle can be prevented by finding an approaching pedestrian or an obstacle using a horizontally scanned 2D LiDAR, as well as the low-speed vehicle on public road. The falling of the vehicle can be avoided by finding stairs using a vertically scanned 2D LiDAR. Its performance level should be D for mobile servant and E for a person carrier, but it also shall depend on the use case. Alarm may help a pedestrian to notice the vehicles as well. This slide shows the required performance level described in ISO 36914. The performance level of the collision avoidance with the pedestrian is specified to be D in this standard. This slide shows the required performance level described in ISO 13482. The performance level for the collision avoidance is specified to be E instead of D in ISO 136914, but the performance level can be modified depending on the risk assessment for a use case. This is a summary and some perspectives. The type of mobile vehicle include automobiles, middle-speed vehicle, low-speed vehicle running on a public road, and indoor vehicles. Safety regulation and international standard should depend on the type. Their applications have started from indoor vehicles and are going to be extended to those on public road with a low, middle, and high speed in this order. Thank you for your kind attention.
Thank you for a good presentation. It was very clear to me that there are different categories of mobile device, and that they have different safety standards. So do you have any comments or questions? Okay, from me. So what is the major difference among the safety requirements for automobiles and mobile robots?
Well, so the automobile is heavier, and also its speed is much higher than robot in general. And also the environment of the automobile cannot control. So we can control the environment, working environment of the robot, for example, as a flat floor, and also can limit people that can enter the space. But in the case of the automobile, it's very difficult to control the environment. So the Safety requirements should be much strict for automobile. So most of the country regulate it by traffic law, and also it's not arbitrary. It has forced regulations. So in case of robot, so especially in Japan, now government try to regulate it as by the safety guideline instead of the traffic laws, because the risk of the robot are much lower than that of the automobiles.
Oh, okay, thank you. Thank you very much. Okay, let's go to next presentation. Okay, the next presentation will be Emma Johansson from Volvo. The title is Toward Vision Zero, Human Factors and Automation. Please.
Thank you very much. I'll share my screen. I hope you can see it.
Yes, okay.
Okay, thank you for inviting me. Very happy to be here. My name is Emma Johansson. As you said, my presentation will present a bit how we work at Volvo on Vision Zero within the traffic domain. Just a short introduction. So I'm a researcher here at Volvo Group Trucks Technology, and I have a background in cognitive science and interaction design. And I've worked a lot with accident investigation and try to find good detection and assessment metrics and tools for detecting drowsiness in drivers and distraction, for example, due to that you fiddle with your mobile phones or enter destination in your navigation system and such. But the last 10 or 15 years or so, I worked a lot with our active safety systems and also higher levels of automation. And just to explain that I'm part of Volvo Group, so we produce trucks, construction equipment, buses, and so on, and we're a global company, so we have products all over the world. I would just shortly show this old nice truck from way back in the time, approximately 100 years, I think. As many of you know, Volvo has always put safety high up. It's like a part of our brand, and that was shown by our founders. They put safety on top as a top priority already in 1927. So, and for us who works in the company, I think everyone feels that safety has been a guiding star for them. And in Sweden, we also have a long tradition of working towards zero accidents. We have, for example, a strong collaboration with other research organizations, vehicle developers, universities, and so on, as well as the Swedish Road Administration. So we obviously focus on our products that we develop within our company, but we also work jointly in different projects and activities dealing with a more systemic view. So obviously the Swedish Road Administration has a strong focus on the road design and so on. There's a picture of two colleagues of mine, and in order to develop the right countermeasures for accidents and incidents, we need to understand the causal factors, of course, why they happen. And we need to understand the reality of the truck drivers themselves and how our products are used by them and how they act in the traffic scenario situation. So we have, for example, our accident research team. It's a team that we have ongoing since 1969, and they carry out on-site investigations, but they also focus on looking at different data sources and carrying out statistical analysis and so on. So this is how we try to understand what we should develop and improve in our products. This is just a page based on data from World Health Organizations, and it just stresses how important this is. Each year, approximately 1.3 million people die in road traffic accidents, and of course, many more are injured. And it's a very, and it feels that, one important factor is that there are often very young people who are injured or killed in the accidents, and many accidents involve vulnerable road users such as pedestrians, cyclists, and motorcyclists. And of course, from our truck perspective, it's important to work with improved sensors, improved line of sight, work with blind spots you have around the truck and so on. Often when you analyze accidents, people stress the human error is what causes most of the accidents. So if nothing is broken physically or such, typically human error is what is searched for. But I like what Nancy Leveson and Sidney Decker often stress in their work, that you could toss it around so you can see human error as a symptom and not a cause of a system which needs to be redesigned. You basically get more to work with if you have that philosophy. So instead of just blaming human error and it kind of becomes like a dead end. So instead we need to figure out what caused the human error, and then you can look at how we have developed our vehicles, for example. And another important factor is that you need to look at the human abilities, not just what people do wrong, but what they actually do right, because we, especially with the truck domain, we're dealing with professional truck drivers who have this as their profession, and they drive a lot and they're very skilled. And it's important then when we design our products, how to consider that they are actually really good, and how to define not only the human limitations and abilities, but also the technical ones, and how they can work together, humans and our machines. We also have to understand that humans are really variable, so they can be both good and extremely bad. They can be really good at decision making and path planning for complex traffic situations, as is seen in those pictures, for example. We are all good at making prediction and anticipate upcoming events and behavior of other road users. So this is a really good skill that we have as humans. And we are quite good at adapt and respond to completely new and unexpected scenarios that we haven't foreseen or haven't been involved in before. But then accidents still happen. So what do we do? Within our vehicles, we need to develop really, really good interaction design. It should be good. It should be easy to face forward, look into the mirrors and the road scene. You should have the hands on the steering wheel and eyes on the road. In addition to that, we develop advanced driver assistance systems and higher levels of automation in order to support the driver to stay attentive. Here's a picture of a former colleague of mine who's looking tired. We want to make sure that the drivers maintain safe speed and distance to the vehicle in front of him or her. And we want to, if that is not possible, we want to mitigate and reduce the severity of rear-end accidents, as an example. And we want to make sure drivers stay within their lane and don't do unsafe lane changes or unsafe crossing across other paths, other people's paths. I just want to show you this is within the traffic context. This is one of the SAE documents that are referred to by many. There are a lot of discussions around it, but I just want to show this is at least one way of looking at automation in vehicles. You have the blue left part here, which is the lower levels of automation where the driver is supposed to be in control. This is what we have to design for. And you have, for example, event-based systems such as crash avoidance, that's level 0. It's kind of like a necessity to have those systems in order to do the level 1 and 2 and 3, 4, 5 systems. Then you can support the drivers with, for example, both either longitudinal or lateral support, then you're level 1. And if you do both, you're level 2. So many systems in vehicles today provide up to level 2. There are some examples in geo-fenced areas and countries which also offer level 3. The one on the right side here, here you can let go of the steering wheel. You don't have to attend to the driving task. You can do non-driving related tasks, etc. So these are 80 automated driving features. So I just want to give some examples on the active safety systems and advanced driver assistance system we have. So in order to reduce accidents, then you have front collision warnings, for collision warnings, and emergency braking. You have lane change support and ways to avoid unsafe lane departures. We have our driver alert system, which provides alerts when we see signs of fatigue, drowsiness, or visual distraction. And then we have upcoming regulations now on intelligent speed assistance. So if you go beyond the speed limit, we will inform the driver about this and warn. And all these systems are designed to assist, so they don't replace the driver. You're supposed to attend to the driving task and have a situational awareness in order to be able to predict what's going on in your surroundings. Then we have more autonomous solutions, and here's just a picture showing the different traffic domains, basically. So you can have confined areas within a mine, for example, where you can have autonomous solutions, or you can have it on a harvest area or on a geofenced highway, for example. And here's an example from one of our projects that we are carrying out now, where we have our Tara is the construction equipment, and our truck driving autonomously in a confined area. So when we work, regardless of if it's active safety and advanced driver assistance systems or it's higher automation, we consider, I mean, a lot of focus is obviously on the human in the vehicle cab. But as the previous speaker said, we also need to consider the humans around the vehicles, the distracted pedestrians, for example, or other road users in other types of vehicles. Perhaps if we drive with high automation, how will our truck behave in relation to the other trajectories, the other vehicles' trajectories? So here's an overview. We also provide different design recommendations, and many of these are done in joint collaboration in EU projects, for example, or other international collaborations with other stakeholders, both OEMs and universities. But for ADAS, we need to, one of the key things is to keep the driver in the loop and make sure that she always feels in control of the vehicle. And this you could do by different means. You could obviously display the mode of the vehicle in the interior, but you can also, by different means, by the steering authority and so on, control the way you keep the driver in the loop. You need to communicate, the function needs to communicate their intended use, so the driver doesn't overtrust the system and expect support that may not be available. This is very important. You need to guide the attention where the area of relevance is. You shouldn't stare down in the interior or elsewhere. You should, we should kind of help the driver to focus on the right areas where there might be an accident or something critical in the traffic scenario. And we need to provide warnings which are clear, brief, and understandable. So this should be like very, it should be very easy to interpret them, should be very intuitive. It shouldn't take a long time at all. We have, and when we do it, we should reflect the criticality, urgency, and nature of the situations. And we should design the system intervention so that they're aligned with drivers' own intent and actions. And for example, if the driver wants to steer and the system brakes, or vice versa, this could create different not so optimal situations. So it's important when we design our system interventions that we also study how the driver would do in a similar situation and try to make sure that they match each other, that we support them and maybe just provide intervention but earlier. And then you have warnings in information. They should be consistent across the different functions so that they follow a design principle, so they don't, the way we show which systems are active and not, and if they're able or disabled, for example. And this cloud that I entered here, it's to show that we want to avoid this featureism. As much as possible, we want to group functions. So for the driver, they might not consider the different sub functions that we introduce in the vehicle. They should just know that they are intuitively supported by the vehicle technology. For higher levels of automations, there are a bit different research questions and design recommendations. So we need to make sure we design safe driver or system-initiated transitions of control. If control is transferred throughout the trip and process, it might not be that you have a driver in the actual cab, or you might not have a cab at all. But if you don't, maybe you have a remote operator where you need to have safe transitions of control. You need to, if you have a driver or an operator, you need to avoid unintended deactivation by the logical design of controls and information. So this should also be done very intuitively, so it should be safe by design. If you have a driver operator who is supposed to be able to regain control at some point in time, you need to make sure that they have the right tools and knowledge and information and so on, so that they can do that. So they need to have a proper situation awareness. And you need to, here is a picture from our truck in the mine, rendered image, of course, but it's important to provide clear cues to external road users. And there has been a lot of activities in this field within the human factors groups within ISO, for example. So there are good material and contacts there. Thank you. That's all I have.
Okay, thank you. Good presentation. So do you have some comment or questions?
Yeah, I
Okay,
have one question. So when the automobile is out of the ODD, then the driver should take over the driving. But it should be a difficult situation when the vehicle is out of ODD. So, but if you switch the system too early, so then the portion of the automatic driving duration maybe too little. So, what is you think guiding principle when we should switch from the automatic driving to the human?
Yeah, good question. So obviously there are different regulations all over the world, but in Europe and the UNEC, I think you have the ALKS regulation, which basically stipulates that if you have, on the right side there, they say if you have level 3 vehicles, they need to do a minimum risk maneuver. So they basically need to have really good technical available systems on board. And if some sensor fail or something else is going wrong, maybe a snowstorm, unpredicted event, they need to slow down. So I mean, there's been a lot of papers written all over the globe, peer-reviewed, on transition of controls, where you basically toss back the control to the driver. And I think everyone by now knows that's a bad idea to do. So regardless if it's an operator sitting, being overwhelmed by that task, or if it's a person in the vehicle, to toss back control in a split second, it's not a good design decision. So I think now in the regulatory bodies, this is they're kind of acknowledging this fact as well. But then of course you can argue what is a good time threshold and so on, and there's been lots of studies from 8 seconds to 45, and you can also look at the quality of the takeover and so on. So yeah, I would say not do it at all. I don't know if it's a good answer.
Okay.
Yeah.
So I believe the investigation of the human factor is very important, I think, to have
so
a
too.
very nice design. So
yeah,
so good luck.
Thank you.
Thank you. It's very interesting presentation. Thank you. Okay. Thank you so very much for taking time out of your busy schedule to give your presentation. So I'd like to close the session now. Okay, please. Thank you. Thank you. Thank you very much.
You.
So the next presentation will be Dr. Hiroki Murakami from IHI. The title is "The Challenge for Field Robotics changing outdoor works. Okay, are you ready, Dr. Brown?
Yes.
Okay, please,
Yes.
please start your presentation.
Thank you for introduce Dr. Tanigawa. I'm particularly honored to have been invited to speak at the session in Vision Zero Summit Japan 2022. So today I talk about activity of challenge for field robotics.
Murakami-san, can you share just slide?
Sorry. Just a moment, please. Sorry.
Okay.
Okay.
Okay. It's a slide show. Slide. It is just not.
Okay.
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 Okay. Please.
Thank you for the introduce, Dr. Tanigawa. I'm particularly honored to have been invited to speak at the session in Vision Zero Summit Japan 2022. Today, I talk about activity of challenge for field robotics in my IHA corporation that aim to the purpose of the challenge change outdoor works. At first, I briefly introduce IHA Corporation that I'm belonging about 35 years. IHA's history extended back to the establishment of Ishikajima Shipyard, Japan's first modern shipbuilding facility in 1853 when Commodore Marshall Perry visited Japan first time. The company played a key role in Japan's modernization, including by relying in shipbuilding technology in new areas, such as heavy machinery manufacturing, bridge building, plant construction, and air engine production. In 1960, Ishikajima Heavy Industries, the successor of Ishikajima Shipyard, merged with Harima Shipbuilding and Engineering to create Ishikajima Harima Heavy Industries. The name IHA Corporation was adopted in 2007 to help strengthen the company's global brand. IHA Corporation is a comprehensive heavy industry manufacturer working to create value for customers in 4 main areas: the resource, energy of environment, social infrastructure and offshore facilities, industrial system and general purpose machinery, and air engine, space, and defense. This figure explains consolidated the sales by business segment in 2020. So I challenged the application of the robot technology to field work as the heavy industry company. Safety is demand from the outdoor site work more than before. The outwork used the heavy industrial machine, but the lack of workforce, the expert operator, once more. Therefore, we are developing to make robotized work system by installation of unmanned unit on heavy industrial machinery. The first step is the machinery operates directly the operating device used by the operator. That's centered. And for electronically connected machine and control machine, it operates by connecting with electronic signals, usually use CAN control area network. By unmanned operation, the operator can operate from a safe place, and autonomy makes it possible to operate without labor saving or expert skill. This system realized to the applied robotic technology, AI technology, sensing technology, and so on. So now I introduce the technology of the autonomous vehicle called UGV that is developing testbed platform, this picture. UGV has two main functions. One of them is perception. That is the environment recognition for off-road. For example, detecting obstacles, estimating ground surface, identify own position in field. The other is planning for the motion trajectory and speed. To realize these functions, UGV has various sensors, for example, stereo camera, 2D or 3D LiDAR. LiDAR means laser imaging detection and ranging. And using multiple sensor data, make a sensor fusion technology recognize the environment and determine the travel area. The type of this UGV is all-terrain vehicle, but multi-platform of the unmanned robotics unit are available to attach van or dump truck or so on. In this slide, the example of the technology used in UGV. The UGV is developed using the control and robotics technology. For perception, terrain estimation, and vegetation recognize are used. In the perception picture on the left here, the blue area means flat area to some extent, and red area is not flat here. For planning, motion planning or path planning are used. Pink area means obstacle detected by some sensors. And blue curve means trajectory as a result of path planning based on motion properties of the vehicle. We also developed operation control unit for the teleoperation of UGV for recovering for energy emergency. And next, this picture is an example of an experiment in which these technology are installed and autonomous driving is performed. There are safeguards in the experimental area for safety. If the safety guard determines that the vehicle has behaved abnormally, it is emergency stop the vehicle with a wireless emergency switch. It is necessary to build such a monitoring system for autonomous driving system. This video autonomous driving, but you can't see the safeguard out of the range. He is keep the safety. So it is very important that keep the safety here. Next, as an application of the technology, we are developing the automation of tractor trailer in this. It is possible to carry various items by using a tractor trailer, but recently the shortage of drivers is a social problem in Japan. So we are aiming to install an automated unit on tractor and apply it to container yard or heavy duty manufacturing plant. Now, this is one of the activity of this area. And next, I introduce the activity about unmanned construction system. For disaster response construction system using teleoperated construction machine reduce risk of accidents in the dangerous area. Operator in safety cockpit operate a machine using wireless communication. This system has become more sophisticated due to the technology advance, such as wireless communication and video comparison. And this system is unique and innovative, developed in Japan. And this unmanned construction system started about 2 years ago. So long time. And recently, IHI working on this technology. So I introduced RoboQS as a practical application of an unmanned construction system. This system is installed on the driver's seat seat to enable a general purpose hybrid excavator remotely. This system be also to attach various excavator to machinery, operate directly the operating devices used by the operator. And available package by air carrying, so this system responds in the early stage disasters. It needs just 2 hours to attach the system on the machine. So easily to use early stage disasters. Characteristic of this system, two-way operation. One is remote control and another is ride-on operator and driving. This system already is used for actual disaster response and aim to expand to dangerous work in ordinary outdoor works. This is a video of the RoboQS system. Here the operator looking the machine and the operator of the safety area. And next one, other activity of unmanned construction system, development of new technology for unmanned construction is introduced. The target is achievement of agent remotely control to work at water site without forcing human workers to approach water's edge, such as reinforcement of riverbank by sandbank and removal of underwater obstacles that hidden river flow. The heavy carrier robot for transportation work in shallow water area is developed based on electronic control type carrier connecting CAN control area network. This one. And this is a communication system for remote control. This system is equipment with 3 wireless communication. The specific low power radio is stable, but the communication capacity is small, so switch operation in emergency and simple maneuvering in early stage of the desire are assigned. The 5 GHz wireless LAN has a large communication capacity, but it is a little unstable. So information that is not vital to control such as image transmission is assigned. 2.4 gigahertz wireless LAN assigned the control information and monitor information mainly. Communication stability is important because the system will be terminated urgently if communication is lost because real-time control. Sorry. This picture is a result of this heavy carrier robot in field. These are remote control of the safety area, and this upper picture very long range, about 2 kilometers distance. And this on the side of the right picture, remoted directly. So the conclusion of this presentation, the method of installation of unmanned robotic unit on conventional machine or vehicle has two merits. Quickly development to apply a reliable mechanism. And second, developing and improvement autonomous level is step by step to developing and installing. Problem of to implement autonomy mobile system in field. It's one is the safety monitoring system is very important. And second, stable wireless communication system is most important system. And it is need to the system design assuming communication interpretation. Future important problem is security of wireless communication system. It will be necessary to be careful that the wireless communication is taking over maliciously. Okay, thank you for your attention.
Okay, thank you, Dr. Murakami. So, are there questions or comments? Okay, from me, so in the conclusion slide, you mentioned the problem. So last problem is what kind of system is considered a coping well recognition?
Yes, so you know that in an outdoor environment, sensing is difficult because of effect of the sunshine or another kind of the weather is difficult, and the environment is often unrecognizable. So therefore, it is recognized by sensor fusion, but it may not be accuracy now. So in recognition, it is servable to set not only normal and abnormal, but also unknown situation result. And unknown state, it is make a control system, control situation of the unknown result.
Okay. Okay. Thank you. Okay. All the presenters are very interesting. So thank you very much for taking time out of your busy schedule to give this session.
The next speaker will be Dr. Tomonori Sawada from Kawasaki Heavy Industries. The title is The Necessity of International Standards and Regulations for Social Implementation of Robots. Please start the presentation.
それでは共同ロボットの社会実装のための国際規格と規制の必要性について、川崎重工業株式会社真田智則から発表いたします。この最初に見ていただいている資料は IFR から毎年発表されるロボット密度と言われる資料です。ここに挙げた、国の中で半導体産業の盛んなシンガポール、韓国では、非常に比率が高い数字が出てますが、それでも従業員1万人あたり 9% ということで1割もいっていません。そして工業先進国と言われる日本、ドイツ、アメリカ、中国に至っては 5% を超える国はまだ存在しません。これはロボットの普及率として高いものとは私たちロボットメーカーは決して思っていません。ですので、このロボット密度の比率を上げるためには、次なるロボットが必要と思っています。それは、共同ロボットと言われる人と共存、もしくは協調するロボットの製品開発が必要だと思っています。例えば、工場内の搬送への適用例ですが、人の作業にロボットが導入される場合、企業ごとに独自の安全基準が採用されています。そして私たちロボットメーカーは、それぞれの企業の個別の規格対応や実証導入実験が必要になってきます。これらを解決した一例として、物流業界の荷下ろし作業を標準化したロボットの事例をご紹介したいと思います。
なぜこれまで荷下ろしの工程の自動化が進んでこなかったのかをご説明します。コンテナにさまざまな形、重さの荷物が積まれているため、コンテナの隅の方に積まれている段ボールへのリーチ、コンテナの奥深くまで入り込んでの荷物の取り出し、異なる形状を認識して荷物を端という3つの条件を同時に満たすことが必要でした。そのためこれまでは人がコンテナ内の荷物をベルトコンベヤに乗せ替える、もしくはフォークリフトでコンテナから荷下ろしをしていました。この工程を自動化するために川崎重工が新たに開発したデバンニングロボットがバンボです。幅広い可動範囲と大きな過半重量を併せ持つ垂直多関節ロボットアームと無軌道の無人搬送車を組み合わせ、マッピング方式によりコンテナ内の作業位置まで移動することが可能です。バンボはコンテナ内まで自走し、ハンドに取り付けられたビジョンで段ボールの形状を認識します。そして段ボールを端し、ベルトのついたハンドで引き込むことにより、さまざまな大きさ、形状、強度の段ボールをコンベヤへ搬送します。これらにより、これまで実現困難であった荷下ろしの自動化を実現します。バンボによってコンテナから荷下ろしされた荷物は、さまざまなサイズをビジョンで認識し、自動でサイズごとにパレットに移し替えられ、自動倉庫に入庫されます。
さらに、下流への物流作業へのロボットの、適用研究開発事例をご紹介します。屋内から屋外へのロボットの適用範囲を広げようとすると、例えば陸、海、空の環境では、それぞれに独自の規制が存在します。しかし、これらの規制や法律は ロボットに対応しているものではありません。そのため、要求仕様の適正な評価ができないのです。それでは当社が考えるラストワンマイルの実現の研究開発事例をご紹介します。
現在、労働人口の減少が大きな社会問題になっており、2030年には644万人の人手が不足するとされています。近未来モビリティにおいては、労働現場に存在する物を動かす工程を効率化し、労働力不足解消を目指しています。物流分野において、e コマースの発展による商品の取扱量の増加と人手不足の顕在化が重なり、効率化が喫緊の課題になっています。また、医療といった一見物流とは関係ない分野でも、本来の医療行為に人的リソースを投下できるように、非医療行為である医薬品や医療機器の運搬など、病院内の物の動きを効率化する必要性に迫られています。この社会課題に対して、ロボティクス、モビリティ、航空の技術を持つ川崎重工が新たなソリューションを提供してまいります。モビリティとは本来、人や物の移動手段、交通システム、乗り物などの意味で用いられます。そのモビリティに無人化、高い走破性、ロボットアームなどを加え、新たな価値を提供できるモビリティを近未来モビリティと位置づけています。現在、物運びの多くの部分を人が担っていますが、これを人がやらなくても良いところ、人がやりにくいところ、人手が足りないところから近未来モビリティを活用し、人を介さない物流に変えていくとともに、将来的にはさまざまな要素技術を組み合わせて無人でできることの対象や、運べる距離、物量、場所、時間短縮、付加価値など多岐にわたる発展を目指しています。それらの一例として、損保ジャパン、ティア4、川崎重工の3社共同の自動搬送ロボットの共同開発及びサービス構築、世界初長野県伊那市無人 V トール機による物資輸送プラットフォーム構築事業、藤田医科大学病院内におけるサービスロボットの実証実験、以上のような取り組みを行っています。
それでは先日行われた国際ロボット展でのデモンストレーションの様子をご覧ください。このように公共的な環境でロボット活動空間を拡大しようとすると、もともと公共的な環境は人とロボットの共存が前提ではありません。よって、どのような法律や規制が対応するのかも決まっていません。その結果、保険などの救償制度がないので、製造メーカーは訴訟問題への発展が懸念されるのです。それでは次に、新しい領域の共同ロボットについてご紹介します。左は変形移動するロボットの例です。運搬具にもなったり、乗り物にもなったりします。 しかし、こういうロボットを規制する法律がありません。右は人と協調するロボットの例です。車椅子を押して人を支援するロボットですが、こういうタイプのロボットへの人への安全基準が、安全確保への基準がありません。それでは、変形移動するロボットの研究事例をご紹介します。川崎ロボットヒューマノイドプラットフォーム、ロボット、VEX のデモンストレーションの例です。それでは次に、人と協調するロボット、HRP シリーズフレンズのデモンストレーションの例です。最後に、ロボットの作業環境は工場内から公共的な環境へ拡大していく必要があります。しかし、工場の場合、交通機関としての役割、また公共の場でどのようにするのか、法律や規制はまだまだ全然決まっていません。そして、これからは従来のカテゴリーにないロボットの形態も出現してきます。こういったものに対しても、次のことが必要になってきます。作業環境や 性能指標の国際規格があれば、すなわち開発仕様が決まるということになります。それは開発のスピードを上げ、そして開発や導入の事前の評価が可能になり、部品産業などの周辺産業、いわゆるサードパーティーが起こり、そしてまたさらに新しいカテゴリーのロボットの議論が可能になっていくのです。規格があるからこそ人との安全を考えられ、そして人と機械を協調させるためにはルール作りが必要であるということをここに皆さんにお伝えして、川崎重工の発表を終わらせていただきます。ご清聴ありがとうございました。
The next speaker will be Dr. Walter Eihendorf from Deutsche Verkehrssicherheit DVR. The title is Vision Zero Road Safety and the Way to Automated Driving. Please start the presentation.
Dear Tamio, many thanks for your kind introduction, and also many thanks for a full year in which we discussed the title of this session and the title of my presentation. It actually is exactly a year ago, on the 11th of May 2021, when you first contacted me and asked whether I would be willing to give this presentation. Dear friends and colleagues in Japan and all around the world, at a Vision Zero summit, I will of course speak about Vision Zero. I will speak about road safety, and following the title of this session, I will connect this to automated driving, and in particular I will discuss with you about the way to automated driving and what that means for road safety and for the Vision Zero. First, a brief look into the German Road Safety Council. It truly is in Germany the umbrella institution, the only one. It was founded more than 50 years ago, and we are the umbrella for all private and governmental institutions involved in road safety, having about 200 members. Our strategy, you can see on the screen, it clearly is Vision Zero. Nobody dies, everybody arrives. But we do have a line below that, and that is what I would like you to think about. Every accident is preventable. What does that mean? It means if an accident has happened, basically every person of you know afterwards how it could have been prevented. So our approach must be that we come in front of the accident, that we use this knowledge, and then we are able to prevent all accidents. Vision Zero has the word vision in the title. It's not truly a vision. It should not be a vision. It's sometimes called a philosophy, but actually it is a strategy. It is the strategy of thinking how to get rid of the accidents. And if you take the example of Vision Zero in traffic, then the first line, of course, says life is not negotiable. That means there cannot be a discussion whether life is first ranking, second ranking, or third ranking. Life is a right, and life is not negotiable. That clearly means that tolerable limits are those of the human beings, and human beings have a right to a safe transport system. But although these three statements you probably all agree, there's one thing we need to think about, because human beings are fallible. Human beings do make mistakes. Think about your way today to business or home. Think about your way yesterday and 2 days ago, and you will immediately realize that there were a number of steps during your last days where you made a small mistake in traffic, a small mistake, and nothing happened. But thinking about the system of road safety, thinking about Vision Zero, we must take into account that human beings do make mistakes. But a mistake in traffic may never be punished by death or severe injury. And that is the idea of the Vision Zero strategy. If you look on this picture, you immediately realize that Vision Zero is among us, namely using airplanes, private airplanes, commercial airplanes. We all know that it is extremely rare that in civil aviation a fatal accident happened. And if it happens, it goes all around the world. It is in all news. Everybody discusses it. It usually even leads to the fact that a typical plane will never be used again, or that even the whole bunch of planes which are similar are taken out of air traffic for a year, 2 years, or 3 years. That is the way how Vision Zero was achieved in civil aviation. And if you look on this, this is air, this is following the air down to the earth. That is trains. And there in industrialized countries, you have the same situation. Train accidents are extremely rare. And if they do happen, it is the same story. They are in the news, not only for days, but for weeks. It is discussed and debated how that could have happened. And usually it never happens again. So Vision Zero is reality in train transportation. But if we look on our roads, this is a picture of a road where, of course, at this moment, there is Vision Zero. But in Germany, we are proud that we have less than 3,000 people that are killed in traffic every year, down from more than 22,000 50 years ago. That is a success, but what is the reason that we are not so successful as in civil aviation or in train transportation? Here's a website designed by DEKRA. At the right side of the picture, you have the link, and I invite all of you to really go to this website. It covers most of Europe. It also covers Japan, and it shows those cities that have reached Vision Zero. Not only just once, but the green dots are cities that reached Vision Zero 6 times, meaning 6 years. And if you look on these small numbers on the top, you see there is, on this picture in Europe, there are 383 cities with a full year of Vision Zero. Nobody died. And if you go along to the green dots, you see even 51 of them had 6 years of zero. 6 years where nobody was killed. So Vision Zero is possible. Vision Zero is within our reach. And what I would like to show you is that applying 10 measures only, 10, nothing more than that, some 90% of all fatal and severe accidents can be prevented. These are the first 6 of the 10 top postulations of the German Road Safety Council. Supervision and enforcement is high ranking, because without that we have no chance. Speed limits is another topic. Accident on trees, a very, very regular topic in many countries. For some countries it does not play a role. Same is true for motorcyclists. The next one, for many countries, particularly in Asia, motorcyclists is a top topic. For other countries, not so much. The infrastructure we will discuss a little bit later, and you will see there's a huge potential. And then, of course, following the topic of this session, ADAS, cross-linking, automated driving. Then comes the safety of pedestrians and cyclists, alcohol and drugs, novice drivers, and reduce hazards through distraction. A topic which is really getting more and more important. But think about it, these are just 10 topics, and with these 10 topics, we cover 90% of the fatal and severe accidents. And in all those cases, we must look on the 4 pillars you are seeing here in this circle: vehicle, road, human beings, and the rules. And I will give you a few examples how that looks like. This is a picture from Germany. It is a picture in which you see pedestrians and cyclists, the vulnerable road users. Actually, in Germany, about 20% of the people that were killed on the road are those vulnerable road users. Now, filling this circle, you see on the upper left, vehicle. What can we do about the vehicles? There are quite a few things possible, but the 2 top ones, they are listed here: brake assist and pedestrian detection. Concerning the roads, it means that the infrastructure must be designed in a way that it is easy to be used also for the vulnerable road users. We have a website of DVR in which you can see best practice of good streets in towns. And there you see how those streets looked before and how they look afterwards. And you see sometimes, and I will give you an example about that, it just needs a little bit of paint and not much money. The rules are important in such a situation within cities. In Germany, we do have a new law saying that if you want to pass a bicycle, you need a minimum distance of 1.5 meters, which is a lot. But we have a lot of cyclists which have a small camera on their helmet and keep that running all the time. And if you pass those cyclists with less than 1.5 meter, that picture is going to be sent to the police. Another topic are motorcyclists. And there again, you can see those 4 pillars. It starts with a vehicle, and there the anti-lock brake system is a very crucial thing because it avoids those nasty accidents where the driver of a motorcycle loses control. The recommendations for the road, here is the name of a German recommendation, but many of them are around the world. They should be followed and applied. A critical topic for motorcyclists is speed limit and controls. Pretty difficult to handle, but very important. And on the lower right, the human beings. And what do we mean about human beings here? Most motorcyclists do not use their bike during winter time. And that means after half a year of not use, they start again. And that is the moment where they should use a training every year in spring, just a fresh up training. Next topic is the infrastructure. Here you see one example that really tells you that with little work and little money, you can reach a lot if there is a lot of brain, if there's a lot of thinking how to solve it. This originally was a crossing with having a lot of accidents, and it was devoted to a circle. And the crucial thing which were really successful here is what you see on the upper right. Visible areas at crossroad and self-explanatory. I'll go back to the previous picture, and here you can see what was done in converting a crossroad to a circle is just paint. It was a lot of thinking, and some paint. That doesn't cost money. But you see that the cars, the bicycles, and the pedestrians, they can all see each other. And the white lines that were painted are in a way that the cars are automatically guided in the way where they should be. And converting this crossroad to a circle led to the fact that there was no accident, no severe accident anymore. Alcohol and drugs are a topic in many countries. Preventing them is not so easy. It should be the way how it is handled here, giving the key to a person that did not use alcohol. In the EU, 25% of fatal and severe accidents are caused by alcohol and drugs. Our position at the German Road Safety is quite clear. We are in favor of a ban on alcohol and traffic. Either you drive or you drink. That is a clear choice, and then we would get rid of these accidents. But of course, and that you see on the lower right, supervision, enforcement is necessary to reach this. And then our main topic in this session, ADAS and automated driving. That is the topic that can really do most of what we need to take. Look on the upper left, there it says ACC, brake assist, and blind spot assist. And the ACC that was also shown in the previous picture here is one of the strongest things on the way to automated driving to avoid accidents, to avoid people getting killed. Of course, we want to go a step further and further and further to partial, highly and fully automated driving. But that means, and that you see on the lower left, that we must have understandable rules of responsibility so that drivers at any stage know how they are supported by the ADAS system and what they still need to do themselves. But quite clear, ADAS and automatic driving is one of the huge steps forward. Here you see in just brilliant pictures the 10 top topics which cover 90% of the fatal and severe accidents. And for all of them, you have these 4 pillars that need to be filled. I just wanted to give you a few examples on a few of the 10, but we do have material on all 10 of them. And if you are interested, just drop me a line and I will keep you informed. But if we are able to prevent 90% of fatal and severe accidents, applying 10 measures only, then I come back to the slide that I showed you before. Every accident is preventable. And as I said before, we must use the knowledge from afterwards to come before the accident and prevent it. And certainly the driver assist systems and the way to automated driving is one of the huge possibilities we do have. The German Road Safety made a clear statement, which is from last year, 2021. We expect that the introduction and use of partially, highly and fully automated driving functions will make a significant contribution to increasing road safety in the future. The important thing about the statement is that we are not just looking on the target at the end and say it will all be safe as soon as everybody is on automated driving. No, we must use the way to automatic driving to increase the level of safety on the roads. I will just illustrate this using one of the many examples, namely trucks. Here are the figures from the EU in the year 2020. And it is on the left side, the HGVs, the heavy trucks, and on the right side, the LGVs, the light good vehicles, lighter trucks. And looking on the two circles, you can see a remarkable difference. The HGVs, the heavy trucks, they kill with 50% people in normal cars. These are the typical accidents on highways, on motorways, where a truck at the end, for example, is bunching into a car and that way killing people. If you look on the right circle, you see a quite huge difference. The light good vehicles, they cause more accidents within the cities. And there you see 39% of those people being killed by LGVs are the vulnerable road users, the VRUs, pedestrians and cyclists. So we must think about those two types of cars differently. There are recommendations by the ETSC, the European Association for Safety, and they are listed here. And actually, much of these 6 recommendations have recently been put into effect. And that was done by the new General Safety Regulation, which was passed by the EU in 2019. It has so many aspects and it has so many assist systems that I couldn't put all of them on this chart. But I put on the 7 that are the most important ones. And the interesting thing is, if you look on this assist systems, then you see 2 columns for new vehicle types. This will be obligatory as of July 22. That is pretty soon. But even for all new vehicle registrations, it is obligatory by July 24. That's only 2 years from now. And intelligent speed adaptation, the emergency stop signal, the reversing detection, all of them are assist systems that do save life. But the 2 ones that are most critical, I've given a red arrow here. The lane departure warning signal and the advanced emergency braking system. And interesting is that those are in effect. They are obligatory for all new vehicle registrations all over the EU from July this year. So that's less than 2 months to go, and all the new trucks will have it. That is a big step towards automated driving, and it is a big step towards Vision Zero. And looking on a few of those driver assist systems that are covered by this EU regulation, the first one is the one that I mentioned before, ACC, and the Advanced Emergency Braking System. We have clear figures that just those 2, ACC and AEBS, can avoid 70% of all truck rear-end collisions. And those are the crucial ones for people in other cars. We have a recommendation by the German Road Safety Council which says that the possibility to switch off the AEBS switch sometimes is necessary under special conditions should be restricted, and the system should be switched on again automatically after a certain time. Because what is happening today sometimes is that the system must be switched off by a driver in a special situation. And if then the driver forgets to switch it on again, it is pretty unsafe driving. so it should be switched on automatically. The turning assistant is a completely different story, and it also targeting on a completely different situation. And you see that in the picture, but you also see it in the first line. Here we talk about built-up areas. Here we talk about large cities. And giving you the example of Berlin, in Berlin 2020, half of the cyclists killed in Berlin died in turning accidents. And it's always the same kind of turning, namely a truck turning right and the cyclist going straight. And even if the cyclist was the one that had the right behind him or her, it doesn't help you. And the turning assist systems, they can reduce the number of these serious turning accidents between trucks and bicycles by about 60%. Again, you see, like with the 10 measures of the German Road Safety Council covering 90%, there are just a few examples, and they all tell you the same. We can reach 50% less, 60% less, 70% less, so it is possible. And here is the future that we talk about in this session, also in the other presentations. It is a future which is not very difficult to reach. It is connected driving vehicle to X, so that all the vehicles and the infrastructure are connected electronically. It will take a few years until a certain percentage of the cars, trucks, and the infrastructure are connected like this. But you see in the lower lines an estimate of the US Department of Transportation, and they say that with sufficient vehicle to X, up to 80% of all accidents could be avoided. That is not fully automated driving yet, but it is on the way to automated driving, and to avoid 80%, of course, that's really a story. A more special topic is the reversing assist. Trucks try to avoid to reverse, but sometimes they need to do it, and that is dangerous, because nowadays the driver of a truck has basically no chance to see what is happening behind this truck. Therefore, in many countries, reversing is allowed using a guide only, but still it is pretty dangerous. And we do have these reversing assist systems with a reversing alert and with a reversing camera to support the driver and help to protect the vulnerable road users. This is not 80 or 90%, but again, it is an important topic. And another one that is pushed strongly by the European Commission is called direct vision. And you see on the picture what it means. It means that a truck driver has so much vision onto the road and to the other road users, in front, to the right, and to the left, that certainly the truck driver had the chance to really find out what is happening around him or her. This is a more difficult topic because it needs the trucks to be really designed in a different way. Therefore, it is mandatory as of 2029 only. But at the German Road Safety Council, we do believe that using the various assist systems that could be reached much earlier. So to summarize that part, the driver assist systems in commercial vehicles, they're able to prevent a large part, a very large part of the fatal and serious accidents, and they allow us to reach Vision Zero. In addition, that should be mentioned, seatbelt is still a topic for truck drivers and can reduce many accidents and injuries for the truck drivers themselves. Finally, Vision Zero is more than that what I've discussed. Vision Zero with the 7 golden rules is a topic that can cover many parts of your life. It can also cover your work. It can cover you at home. These are the 7 golden rules of Vision Zero, which I cannot discuss in detail because that is a different topic. My recommendation is that you listen to Helmut Ehnes 2 days from now, and he will go into the details of the 7 golden rules. I hope you follow my story. I hope you follow what I said about accidents that are preventable. Every accident is preventable. It only means that we really come from behind the accident to before the accident. I hope I could convince you, and thank you for your attention.
Dear session chairs and speakers, thank you very much for this exciting first part of your sessions. Ladies and gentlemen, the summit organizer kindly asks you to spend a few minutes to complete a short survey about future Vision Zero promotion activities. Please click on the banner Request for Survey and share your view by filling the questionnaires. Thank you for your kind support. But now it's time for a well-deserved break. During the break, we will show interesting video spots and information from our supporters and sponsors. Relax and enjoy. The second part of the session will begin as indicated on the screen. Please be back on time.
働く環境は多種多様。職場での事故などに起因する怪我や疾病は適切な方策で避けられます。国際安全規格に基づいて危険源とリスクをタイムリーに同定し、適切な保護方策を行うことで怪我や疾病を未然に防ぎ、健康に働くことができます。働く人の安全・安心・健康、そしてウェルビーイングの実現を目指すことが企業価値を高め、より良い社会成長につながります。日本認証株式会社は安全・健康、そしてウェルビーイングの実現を目指す世界の安全新潮流ビジョンゼロを企業活動の指針とし、働く環境の安全化を現場目線で推進する技術と、企業のビジネスリーダー目線で推進するマネージメントの両面から働く職場の安心・安全化にフォーカスし、その実現を推進しています。主な企業活動は3つ。働く人の安全を司る機械、防爆、ロボット、マネジメントの4つの安全要員認証資格。世界各国の製品認証の取得。人と機械の協調安全技術セーフティ 2.0 の適合審査登録制度。3つの観点から労働環境の安心・安全化に貢献します。働く人たちが日々ウェルビーイングを実感できるグローバル社会の実現を推進する日本認証株式会社のこれからにご期待ください。
There's an unstoppable wave of change moving across the global business landscape, cascading through boardrooms, sending ripples through supply chains and beyond. It's time to catch the wave. The COVID-19 pandemic, climate crisis, and rise of social justice movements around the world have all accelerated thinking beyond the here and now. What does it mean to be a responsible, sustainable, resilient business built on solid environmental, social, and governance principles? It all starts with people. It's no coincidence that those businesses setting high standards for the treatment of their workforces, communities, and supply chains reap rewards with stronger performance and growth. Our connected world expects organizations to prioritize public good and behave responsibly. Employees and customers will call out poor working conditions and demand better. But this is not just about doing the right thing. Social sustainability is the backbone of corporate resilience. It supports stronger operational performance and cash flow. And right now, that feels more critical than ever. The environment has been the flagship cause driving the corporate sustainability agenda. Now it's time to put people alongside planet and profit, to unlock and unleash the tremendous value that lies in our global workforce. IOSH is working alongside international organizations, including UN agencies and initiatives, such as the World Health Organization, ILO, and UN Global Compact to harness the collective energy of progressive businesses. Together, we're making a long-term commitment to drive social sustainability forward, with a global force of safety and health professionals making change happen on the ground. Because safer environments and enlightened attitudes to health and well-being, diversity and inclusion are all safety and health issues too. And COVID-19 has shown just how vital it is to protect people. If businesses are not just to survive, but thrive. Together, we can be part of a global network of resilient, profitable businesses and organizations that flourish, equitably and sustainably, around safe, healthy workforces. It's time for a new world of work. It's time to catch the wave with IOSH.
We at IDEC, our main business is HMI, Human Machine Interface. We believe that this will change. So automation will become more and more important. we will also need to address new requirements from people in terms of their own well-being. So again, a lot of new things that we can develop to move forward and provide additional safety and peace of mind.
生産現場では世界的な新しい流れビジョンゼロの考え方に基づき安全文化を作る活動を展開しています。自分らしく能力を発揮しながら働くことができて安全が常に議論される職場を作るために3つのことを進めています。従業員に参加を促すこと、従業員の声を尊重すること、組織横断的なチームで議論して知識を共有すること、全社員が健康で安心して働き、無事に家族のもとに帰ることを実現します。
En Europe, nous attachons effectivement une grande attention à la sécurité et au bien-être. Chez IDEC, nous pouvons nous appuyer sur des produits de qualité. Nous pouvons également nous référer au concept en Chine qui vise à aborder de manière globale l'interaction entre l'homme et la machine. Pour appliquer ce concept, nous avons en Europe des équipes dédiées dans chaque pays qui peuvent communiquer dans la langue du client. Cette proximité nous permet de faciliter les échanges et de trouver avec le client les bonnes solutions.
World dynamics and expectations are changing, demanding a better balance of productivity, environmental sustainability, and worker well-being. That's why we support the Vision Zero initiative. We will continue to raise awareness and develop the enabling solutions as we work to promote the sustainability and well-being into the future.
Ensures workers' sense of security at manufacturing sites. Enhances workers' safety. Secure and reliable access control, advanced authentication and authorization. Autonomous mobile robots increase safety and productivity. Provides a safe working environment for people working with robots. Safety and beyond. IDEC. tiny, invisible bubbles that are smaller than any we normally see. They are fine bubbles. These tiny bubbles can change the world into a society of well-being. Fine bubbles have 3 effects. The washing effect is used in infrastructure, industry, medical application, and consumer products. The purification effect applies to rivers and oceans, and wastewater. The growth-promoting effect applies to agriculture and the fishing industry. Fine bubbles are also used in many other fields, enriching our society and our lives. Fine Bubble Industries Association was founded in Japan. We work with companies and research organizations to develop technologies and put them to practical use. We are working to industrialize them through international standardization and certification systems. In addition to people's living, the bubbles aid in reducing water usage, curbing the use of chemical substances, and reducing our environmental burden. They also aid food stability, nutrition improvement, and marine resources conservation. They help to create a sustainable society. We will develop and spread the amazing fine bubbles. Aiming to achieve the SDGs, we will connect them to the ultimate well-being. That is our wish. These tiny bubbles are full of a wonderful future. Fine Bubble Industries Association.
We do our jobs with sincerity and integrity to make a better living environment for the people and our society. Today's work, tomorrow's heritage. Shimizu Corporation.
日歩は ICT、IoT で舗装現場をつなぐ。新たな取り組みで生産性と安全性の向上、道路技術の最前線でイノベーションを起こす。行け、行くんだ、新たなステージへ。人が歩いた後に道はできる。 NP ネクスト。
働く環境は多種多様。職場での事故などに起因する怪我や疾病は適切な方策で避けられます。国際安全規格に基づいて危険源とリスクをタイムリーに同定し、適切な保護方策を行うことで怪我や疾病を未然に防ぎ、健康に働くことができます。働く人の安全・安心・健康、そしてウェルビーイングの実現を目指すことが企業価値を高め、より良い社会成長につながります。日本認証株式会社は安全・健康、そしてウェルビーイングの実現を目指す世界の安全新潮流ビジョンゼロを企業活動の指針とし、働く環境の安全化を現場目線で推進する技術と、企業のビジネスリーダー目線で推進するマネージメントの両面から働く職場の安心・安全化にフォーカスし、その実現を推進しています。主な企業活動は3つ。働く人の安全を司る機械、防爆、ロボット、マネジメントの4つの安全要員認証資格。世界各国の製品認証の取得。人と機械の協調安全技術セーフティー 2.0 の適合審査登録制度。3つの観点から労働環境の安心・安全化に貢献します。働く人たちが日々ウェルビーイングを実感できるグローバル社会の実現を推進する日本認証株式会社のこれからにご期待ください。
there's an unstoppable wave of change moving across the global business landscape, cascading through boardrooms, sending ripples through supply chains and beyond. It's time to catch the wave. The COVID-19 pandemic, climate crisis, and rise of social justice movements around the world have all accelerated thinking beyond the here and now. What does it mean to be a responsible, sustainable, resilient business built on solid environmental, social, and governance principles? It all starts with people. It's no coincidence that those businesses setting high standards for the treatment of their workforces, communities, and supply chains reap rewards with stronger performance and growth. Our connected world expects organizations to prioritize public good and behave responsibly. Employees and customers will call out poor working conditions and demand better. But this is not just about doing the right thing. Social sustainability is the backbone of corporate resilience. It supports stronger operational performance and cash flow. And right now, that feels more critical than ever. The environment has been the flagship cause driving the corporate sustainability agenda. Now it's time to put people alongside planet and profit, to unlock and unleash the tremendous value that lies in our global workforce. IOSH is working alongside international organizations, including UN agencies and initiatives, such as the World Health Organization, ILO, and UN Global Compact to harness the collective energy of progressive businesses. Together, we're making a long-term commitment to drive social sustainability forward, with a global force of safety and health professionals making change happen on the ground. Because safer environments and enlightened attitudes to health and well-being, diversity and inclusion are all safety and health issues too. And COVID-19 has shown just how vital it is to protect people. If businesses are not just to survive, but thrive. Together, we can be part of a global network of resilient, profitable businesses and organizations that flourish, equitably and sustainably, around safe, healthy workforces. It's time for a new world of work. It's time to catch the wave with IOSH.
tiny, invisible bubbles that are smaller than any we normally see. They are fine bubbles. These tiny bubbles can change the world into a society of well-being. Fine bubbles have three effects. The washing effect is used in infrastructure, industry, medical application, and consumer products. The purification effect applies to rivers and oceans, and wastewater. The growth-promoting effect applies to agriculture and the fishing industry. Fine bubbles are also used in many other fields, enriching our society and our lives. Fine Bubble Industries Association was founded in Japan. We work with companies and research organizations to develop technologies and put them to practical use. We are working to industrialize them through international standardization and certification systems. In addition to people's living, the bubbles aid in reducing water usage, curbing the use of chemical substances, and reducing our environmental burden. They also aid food stability, nutrition improvement, and marine resources conservation. They help to create a sustainable society. We will develop and spread the amazing fine bubbles. Aiming to achieve the SDGs, we will connect them to the ultimate well-being. That is our wish. These tiny bubbles are full of a wonderful future. Fine Bubble Industries Association.
We do our jobs with sincerity and integrity to make a better living environment for the people and our society. Today's work, tomorrow's heritage. Shimizu Corporation.
日歩は ICT、IoT で舗装現場をつなぐ。新たな取り組みで生産性と安全性の向上、道路技術の最前線でイノベーションを起こす。行け、行くんだ、新たなステージへ。人が歩いた後に道はできる。 NP ネクスト。
働く環境は多種多様。職場での事故などに起因する怪我や疾病は適切な方策で避けられます。国際安全規格に基づいて危険源とリスクをタイムリーに同定し、適切な保護方策を行うことで怪我や疾病を未然に防ぎ、健康に働くことができます。働く人の安全・安心・健康、そしてウェルビーイングの実現を目指すことが企業価値を高め、より良い社会成長につながります。日本認証株式会社は安全・健康、そしてウェルビーイングの実現を目指す世界の安全新潮流ビジョンゼロを企業活動の指針とし、働く環境の安全化を現場目線で推進する技術と、企業のビジネスリーダー目線で推進するマネージメントの両面から働く職場の安心・安全化にフォーカスし、その実現を推進しています。主な企業活動は3つ。働く人の安全を司る機械、防爆、ロボット、マネジメントの4つの安全要員認証資格。世界各国の製品認証の取得。人と機械の協調安全技術セーフティー 2.0 の適合審査登録制度。3つの観点から労働環境の安心・安全化に貢献します。働く人たちが日々ウェルビーイングを実感できるグローバル社会の実現を推進する日本認証株式会社のこれからにご期待ください。
There's an unstoppable wave of change moving across the global business landscape, cascading through boardrooms, sending ripples through supply chains and beyond. It's time to catch the wave. The COVID-19 pandemic, climate crisis, and rise of social justice movements around the world have all accelerated thinking beyond the here and now. What does it mean to be a responsible, sustainable, resilient business built on solid environmental, social, and governance principles? It all starts with people. It's no coincidence that those businesses setting high standards for the treatment of their workforces, communities, and supply chains reap rewards with stronger performance and growth. Our connected world expects organizations to prioritize public good and behave responsibly. Employees and customers will call out poor working conditions and demand better. But this is not just about doing the right thing. Social sustainability is the backbone of corporate resilience. It supports stronger operational performance and cash flow. And right now, that feels more critical than ever. The environment has been the flagship cause driving the corporate sustainability agenda. Now it's time to put people alongside planet and profit. To unlock and unleash the tremendous value that lies in our global workforce. IOSH is working alongside international organisations, including UN agencies and initiatives, such as the World Health Organization, ILO, and UN Global Compact to harness the collective energy of progressive businesses. Together, we're making a long-term commitment to drive social sustainability forward, with a global force of safety and health professionals making change happen on the ground. Because safer environments and enlightened attitudes to health and well-being, diversity and inclusion are all safety and health issues too. And COVID-19 has shown just how vital it is to protect people. If businesses are not just to survive, but thrive. Together, we can be part of a global network of resilient, profitable businesses and organisations that flourish, equitably and sustainably, around safe, healthy workforces. It's time for a new world of work. It's time to catch the wave with IOSH.
We at IDEC, our main business is HMI, Human Machine Interface. We believe that this will change. So automation will become more and more important. We will also need to address new requirements from people in terms of their own well-being. So again, a lot of new things that we can develop to move forward and provide additional safety and peace of mind.
生産現場では世界的な新しい流れビジョンゼロの考え方に基づき安全文化を作る活動を展開しています。自分らしく能力を発揮しながら働くことができて安全が常に議論される職場を作るために3つのことを進めています。従業員に参加を促すこと、従業員の声を尊重すること、組織横断的なチームで議論して知識を共有すること、全社員が健康で安心して働き、無事に家族のもとに帰ることを実現します。
En Europe, nous attachons effectivement une grande attention à la sécurité et au bien-être. Chez IDEC, nous pouvons nous appuyer sur des produits de qualité. Nous pouvons également nous référer au concept en Chine qui vise à aborder de manière globale l'interaction entre l'homme et la machine. Pour appliquer ce concept, nous avons en Europe des équipes dédiées dans chaque pays qui peuvent communiquer dans la langue du client. Cette proximité nous permet de faciliter les échanges et de trouver avec le client les bonnes solutions.
World dynamics and expectations are changing, demanding a better balance of productivity, environmental sustainability, and worker well-being. That's why we support the Vision Zero initiative. We will continue to raise awareness and develop the enabling solutions as we work to promote the sustainability and well-being into the future.
Ensures workers' sense of security at manufacturing sites. Enhances workers' safety. Secure and reliable access control, advanced authentication and authorization. Autonomous mobile robots increase safety and productivity. Provides a safe working environment for people working with robots. Safety and beyond. IDEC. Tiny, invisible bubbles that are smaller than any we normally see. They are fine bubbles. These tiny bubbles can change the world into a society of well-being. Fine bubbles have three effects. The washing effect is used in infrastructure, industry, medical application, and consumer products. The purification effect applies to rivers and oceans, and wastewater. The growth-promoting effect applies to agriculture and the fishing industry. Fine bubbles are also used in many other fields, enriching our society and our lives. Fine Bubble Industries Association was founded in Japan. We work with companies and research organizations to develop technologies and put them to practical use. We are working to industrialize them through international standardization and certification systems. In addition to people's living, the bubbles aid in reducing water usage, curbing the use of chemical substances, and reducing our environmental burden. They also aid food stability, nutrition improvement, and marine resources conservation. They help to create a sustainable society. We will develop and spread the amazing fine bubbles. Aiming to achieve the SDGs, we will connect them to the ultimate well-being. That is our wish. These tiny bubbles are full of a wonderful future. Fine Bubble Industries Association.
We do our jobs with sincerity and integrity to make a better living environment for the people and our society. Today's work, tomorrow's heritage. Shimizu Corporation.
日歩は ICT、IoT で舗装現場をつなぐ。新たな取り組みで生産性と安全性の向上、道路技術の最前線でイノベーションを起こす。行け、行くんだ、新たなステージへ。人が歩いた後に道はできる。 NP ネクスト。
Ladies and gentlemen, welcome back to Day 1 of the Vision Zero Summit Japan 2022. The summit is the result of a collective effort by many different organizations and individuals. It is organized by the Global Coalition for Safety and Health at Work, Task Group on Vision Zero at enterprise level, and the Institute of Global Safety Promotion, in close collaboration with the official co-organizers. We also would like to thank again our supporters and sponsors for their important contribution to the organization of the summit. Please note, the recording, filming, and storage of images of the summit, as well as posting unauthorized use of the summit content, is not allowed. Thank you very much for your kind understanding.
The next speaker will be Dr. Yutaka Hiwatashi from Subaru Corporation. The title is Secrets of Subaru Eyesight. Please start the presentation.
はい、皆さんこんにちは。スバルの日渡と申します。今回はビジョンゼロサミットにお呼びいただきありがとうございました。私の方からは30分程度、自動車会社として自動車の安全、それからそれを軸にしてアイサイトって皆さんご存知だと思うんですけども、運転支援システムアイサイトの、長い歴史、どうやって開発してきたか、それから後半にはですね、自動運転の取り組み、これもやはり自動車というのはパーソナルな普通の一般の方を乗せる車なので、工場設備とはまた違ったその考え方で安全を担保しなきゃいけないということがあります。そんなことを少し感じていただくために、時間いただきましてプレゼンテーションさせていただきます。よろしくお願いします。まずスバルの、会社の、紹介から始まるんですけれども、古い方ご存知かもしれません。もともと戦前の中島飛行機という、会社です。1917年に、ベンチャー企業として群馬県の太田市で設立された研究所が元になっています。で、その後ですね、第二次世界大戦が始まりまして、西の三菱、東の中島ということで、ものすごい、軍事企業になっているわけです。ただその後、これもご存知のように終戦を迎えまして、すべて解体されて GHQ が、来てですね、すべて中島は解体します。ただその後、やはり瓦礫の後をどうやって家族でファミリーで旅行できるかということを考えるために、自動車に仕事を変えてきます。で、富士重工業という名前を経た後、2017年からは、もうほぼ、航空機もありますけれども、自動車がもう9割5分以上になってますので、自動車に特化したブランド名、スバルという、株式会社スバルという名前で、再スタートしているところでございます。ちなみに、私、日本語で喋りますので、わからないところはここにテロップ出てますので、はい、皆さんよく見てください。次行きます。飛行機会社から自動車会社へ、コンバートしたスバル。最初に、設計された時の、これがポンチ絵、車の絵ですね。デザインモックです。で、やはり、家族4人で、ファミリーで、戦後の 瓦礫の跡をドライブしたいっていう夢のようなやっぱり車を作りたくて、まず白抜きに書いてありますけども、大人4人の絵を描きました。その後ですね、エンジンですとかサスペンション、ステアリング、舵取り装置、自動車に必要な部品をぎゅっとパッケージ詰め込みまして、今でいう軽自動車のサイズを最初に実現した、理想的な車だったんですね。で、また、やはり航空機から生まれたカーメーカーですから、ボディがモノコックボディと言います。普通の今皆さんが乗られている車はもう世界的にももうほとんどがモノコックです。トラックとかああいうフレームに乗っかる以外の、ボディに直接サスペンションが刺さってるのはみんなモノコックです。で、これやはり航空機がやはりその同じような形してますよね。卵型構造で、力が加わった時にその力が分散なんですか分散して、力が均等に流れるので、一箇所が壊れることがないという構造です。これが真っ先に日本で初めて取り込まれたのがこのスバル360の特徴です。で、そういって自動車を始めたカーメーカーですけれども、当然ながら、究極の目的というのは自動車事故をゼロにすること。それからもちろん今日は触れませんけれども、環境対応ですね。温暖化を抑える CO2 を出さない。これがありますが、まずは自動車事故をゼロにすることというところからお話を進めます。これはビデオです。先ほどご紹介したスバル 360cc の小さい、最初に作ったスバル車です。モノコックボディ。で、今日お伝えしているのは私、群馬県の太田なんですけども、太田市なんですけども、そこのテストコースに 3×4 メーターの右側に見えます。コンクリート壁をエンジニア自らが作りまして、下の方に実は穴が開いてて、紐で、ロープで右から引っ張ってるんですね。この壁の右側に外車があります。それで引っ張ってます。で、40キロでぶつけてます。で、この当時というのは、その1950年代ですから、安全に関わる法律っていうのはもう全然ない時代に、自ら安全であるべきということで、独自の実験コースを作って評価したのが最初です。それから次は、少し年が経ちますが、今、皆さんレガシーとかインプレッサーという名前ご存知かもしれませんけども、これはそのもう少し前の車で、レオーネという車がありました。その時の、これも私が調べた限り日本で初めての実験ビデオですね。普通は、エアバッグってご存知だと思うんですけど、衝突した時に車の中の人間を守るというのが普通の考え方です。ただご覧のようにスバルは、これ1970年代の初頭ですけども、仮に、交通弱者、歩いてる方を跳ねてしまったっていう非常に稀なケースを考えながら、どうやったら救えるだろうかということを研究していたのがこのビデオです。で、よくご覧ください。これは非常に面白いビデオになってるんですけど、バンパーの下をちょっとご覧いただきたいんですけども、跳ねちゃったっていうショックをセンシングしてですね、出ましたよね、これ下に。網です、網。群馬県には川が多くてですね、多分我々の OB は魚釣りに行ってから来てるんじゃないかという逸話が残ってますけど、たださすがにこれ片持ちというか、片方、これさすがに持てませんね。ただ、それが重要なのではなくて、よくこの高速ビデオを冷静に見てみるとですね、衝突した時にいきなり地面に落ちるんではないんですね。まずこのバンパー、ボンネットですね、ボンネット、フードですね、に頭をぶつけてしまう。ここで一時障害値と言いますけども、最初に頭に加速度がかかります。で、気絶して、その後地面に頭を打ちつけて、2回目の衝撃を受けて、本当に致命傷になる。で、ということは、最初にこのバンパーのあたり、それからカウルと言われるこのワイパーがあるあたりですね。それから窓ガラス。こういったところをいかにこのクッション材にしてあげるかというのが結構、この、アイサイトのような技術が出る前の衝突安全という技術では、ここが非常に大事でした。で、スバル車は水泳対向エンジン、ボクサーエンジンが、これ非常にこの高さが低いので、比較的このボンネットのフードまでの隙間が取れるんですね。クッションになる。 なので、仮に頭を打ちつけても、それほどひどい傷害致は受けないというのが特徴です。そういうことを45年以上続けて、今でもその全方位の安全設計をしているのがスバル社ですけれども、こちらちょっとビジーな絵になって申し訳ないんですけど、いくつか安全の技術について分類したので、簡単にご紹介しておきます。左に示しているのが、いわゆる運転走行中のイベントのシナリオだと思ってください。普通に気持ちよく走っている状態、これ安全状態。それから、例えば、日本ですと左側通行です。右側からワンちゃんが、日本語で言うとワンちゃんですね。英語で言うとドッグですね。飛び出してきたときに、いけないって言ったときに、このハンドルを切って避けますよね。で、避けて、危なかったって、何もなかった場合は、この右側、未然の事故回避ということで安全状態に戻りますね。また鼻歌状態。ただ、ワンちゃん、あるいは英語でドッグがですね、出てきた。で、左に思いっきり切ったときに、左側に今度電信柱があった。もうそれは避けられなかったら事故になっちゃう。ここはどうしても全て救えるケースってないわけで、ただその後、事故起きた後に、先ほどご紹介しましたような衝突安全の技術ですね。ぶつかった後に人命を守る、あるいは歩行者を守るというのがここです。それから最近は IT、IoT が非常に発達してますが、ぶつかってしまった時に乗員そのものがもう気絶して、警察に電話できない。そんな時にはもうテレマティックを使って自動的に緊急通報するというのは、今非常に伸びているものです。例えばドクターヘリを呼ぶなんていうのもそういうことです。で、今日は少し先行きますけども、我々そもそも安全である、この右がスバルとしては4つの分野に切り分けてるんですけれども、特徴的なのはですね、スバルでいうとこのゼロ時安全思想です。これは何かというと、当たり前なんですけど、制御とか電子制御と関係なく、そもそも視界が広いであるとか、四輪駆動で4つのタイヤでしっかりグリップする。それから低重心であること、バランスが前後左右同じであることっていう、その基本骨格と言いますけども、アーキテクチャが非常に安定しているということが大事です。で、その上で初めて、技術の順番で言うと、その一つ飛んで、プリクラスセーフティー、ごめんなさい、一番下ですね、パッシブセーフティー。先ほどお見せした衝突したときに安全なパッケージが2つ目になります。それから次には上から2つ目、アクティブセーフティーということで、いざワンちゃんを避けようとしたときにも、その車体がちゃんと追従することということで、四輪駆動であるとか、パワーステアリングを補助トルクといいます。ちょっと補助力を入れて、ドライバーの足りない力を補うとか、そういったものがアクティブセーフティーですね。それから今日の主軸になりますとこは、その次の上から3番目のプリクラッシュセーフティー、アイサイトって書いてあります。技術が進展しまして、車の中のセンサーだけではなくて、外界を検出して人命を守る。車内を守るし、歩行者を守るというのが、新しい技術で、今日の主題になります。で、我々、アイサイト、あるいはその、衝突安全技術ということを、この2000少し前の16年の車ですけども、インプレッサーで全部標準で装着した、非常にお金かかるんですけど、正直言って、歩行者を守るエアバッグとアイサイトを全部のグレードに標準装着したということで、日本カー・オブ・ザ・イヤー、日本で最も優秀な車ということで表彰されています。じゃあ次いきます。ということで、紹介ここページまでなんですけども、こういったずっと同じ考え方で、思想で安全設計してきたスバル。こちらが我々の車のラインナップですけども、基本的に全て同じ哲学、同じ DNA で設計されています。はい。じゃあいよいよですね、次のセクション、アイサイトの開発について触れたいと思います。すいません。アイサイトはですね、紹介で忘れましたけども、私自身がもう30代の後半の時から始めてます。基礎研究から全てスバルがやってるんですけども、1989年の基礎研究から始まって、私が携わって初めてのステレオカメラの運転試験出しました。で、私ももう随分言いますね。30代の後半から今60、もうすぐ62ですけども、ずっとこういうものを発展させてきたつもりです。 で、アイサイトなんですけども、これは皆さんご存知かなと思いますけども、一応、人と同じように、カメラがですね、CMOS のカメラが35センチ離れたところに、前向きに、車の室内から外向けに、カメラがついています。で、そこで、すべての映像、自然環境、道路、人、自転車、車を、認識しまして、そのデータをもとに、プリクラッシュブレーキをかけたり、追従クルーズ、ACC、などの複数の機能を実現しているのがアイサイトです。こちらが紹介ビデオなので、お見せするぐらいにとどめますけれども、こういうのをご覧になったかなと思います。2010年に発売して、もう10年以上、売り続けてますけども、非常に世界中の交通安全を、先導していると思っています。で、この、機能の開発の、なんていうかな、原理のところちょっと触れたいと思うんですけども、あまり深い話すると時間がないので簡単にします。2つの目、人間と同じように視差を持った2つの目で、全ての映像を撮ります。で、右目が基本になっていて、左目とそのどれだけズレがあるかっていうのを逐次コンピューターが計算するわけですけれども、指を近くにすると二重に見える、遠くにすると1個に見えるということで、視差と言いますね。なので、右目でまず映像一つの、例えば何でもいいんですけど、私ここの部屋だと、あそこに、そうですね、カレンダーがあります。カレンダーを右目で見つけた後、左目でちょっと離れたところから同じカレンダーを探しに行きます。そうすると、当然ながらピクセルが画像上に映る映像としては、ちょっと左側が右がこうずれるわけですよね。左寄りになるのかな。で、そうすると、それを三角速報の原理でひっくり返すと、距離として計算できるわけですね。三角関数で。で、距離がわかる。それから今ちょっと右に向きましたけど、カレンダーは右にあります。画面上に映っている映像の中でカレンダーが少し右にあるわけですね。ということは、左右位置がわかる。左右位置と奥行きが分かれば、映した映像の絶対座標が分かるわけです。で、真ん中の右側に、このカラーの絵が、これが実際に距離画像と呼ばれている、コンピューターの中で、計算している映像そのものです。お客さんには見えないんですけども。で、遠いところが青色、手前が赤い色で、レインボーカラーで奥行きが分かるようになっています。で、このステレオカメラは人間ではありませんから、この中から車線とか、対象物を検出しなければいけませんよね。で、まずやることは、人間ならすぐ分かります。自分の走行車線は、このラインが走ってますので、それを見つければ走行ルートが分かる。それから、右側にオレンジの塊があります。で、これはカメラ塊としか見えませんので、それを横 1.8 メーター、縦 1.7 メーターのように、このフィルターリングかけると、車の後端ということが判定できるので、ID として登録するわけですね。これを立体物としてたくさん用意して検出しておきます。それが、例えば自分の走行車線に割り込んできたときに、距離が短いときにブレーキをかける、そういった機能になるわけです。こちら、今はもう少しカラーなので、綺麗なので、昔の映像、機密の問題もあるので、古い映像ですいません。人とか車とか自転車を分離できていることがわかると思います。で、ステレオカメラ、カメラというと、これは首都高速なので、緑が追従ターゲットですね。カメラというと、環境に弱い、雨とか雪で弱いだろうと思われると思うんですけど、これは結構大雨です。これも大雨、土砂降りの東京首都高ですね。それから北海道、これは銀座の交差点。ギラギラしてても、今はもうほとんど問題なく、普通はレーダーとか言われますけど、カメラ、これステレオカメラで、アイサイトで十分撮れます。これ北海道の猛吹雪の中走ってる映像ですが、そういう意味だとカメラが車の内側、ガラスウィンドウの内側にありますから、わかりやすく言えば、ワイパーが拭いてくれますので、悪環境でも使えるんですね。ただ、さすがに氷ついたり、水膜ができるような水の膜ですと、自分でここが大事なんですけども、自分で判別して、今はダメだということで、ワーニングを出して、ドライバーに主権を戻します。なので、この開発の時にポイントは、安全というポイントですと、グレーを作らないということでしたね。やれる時はホワイトで全部やる。でもダメならば、ちゃんとソフトウェアで判断して、ブラックですね。 ユーザーに戻すという、このグレー、中途半端を作らないというのが、このアイサイトの設計の秘訣でした。はい。で、次に行きます。で、こちら、アイサイトの特徴的な試験映像です。ご覧のように、こちら、ただの段ボール箱に、自分で巻いたから覚えてますけども、黄色と黒の安全テープをペタペタ貼ってるだけですね。ペタペタ。それを転がしてるんですね。前の番から。ところがというか、このアイサイト、昔は AD っていう名前だったんですけど、ステレオカメラを使った我々アイサイトは、こういった非常に曖昧なものに対してもブレーキかけて止まることができるということです。これが、例えば、ほとんど、スバルだけですね、ステレオカメラ。言い忘れましたが。例えば、レーザーレーダー。よくパワーポイントをこう指すと、パワーポイントというか、ポインターですね。あれはレーザー、赤外線レーダーを使ったり、あとは電波レーダー、ミリ波レーダー、電波式の、センサーを使ったりというのが他のカーメーカー非常に多いです。ただご覧のようにですね、この段ボール箱、もちろんビームを当てても乱反射して距離測れませんし、電波を当ててもこれ段ボール箱なので反射しません。ということは跳ねてしまいます。ということは、車だったらまあ止まれるかもしれませんけども、こう人とかこういった曖昧なものに対しては、ステレオカメラでないと無理だということがこれ分かると思います、直感的に。はい、次いきます。じゃあどうしてそんな素晴らしいものができたかって、ちょっと簡単に説明します。これ、1989年、我々の基礎研究所が初めて出した、ステレオ法の特許です。パテントです。で、真ん中がその実施例なんですけれども、これがアイサイトですねって誰も思わないと思いますね。車屋さんなので、これは単気筒1本のエンジンのシリンダーとピストンです。実はですね、ご存知のようにガソリンと空気の混ざったものに、こう、何言うだ、発火させて、バーンってこう破裂してエンジン回すわけですけども、そこの混合機と言われるこの流体が、この1989年ってもう30年前っていうのは、検出する、計測する技術がなかったんです。それなので、それを立体でどういうふうに渦が巻いてるかを検出したいがためにですね、研究してました。なので、このミラーですね、鏡を、これ可視化、要するに中身が透明で見えるようにした状態で、左右に鏡を置きます。それをですね、なんとこれ16ミリの映画用フィルムカメラで撮影して、後でミックスして距離を出して、中の空気流動を観察するような設計を生み出しました。で、これがやったということで、すぐさま右側にありますような3次元立体子、電子回路を権利化しまして、これが今もう時を超えて2022年のアイサイトでも使われている基本原理になります。そこから、今に至るんですけど、この頃ですね、とにかくこの何もない時に、こんな状態の時に、なんとか命を守りたいと、交通弱者を守りたいということで書いた、これはポンチエですね、コンセプトシート、まだ何もない時です。で、信号でも車でも歩行者みんな見れればいいよね。で、車を改造して、いろんなもう当時はもうカメラなんか売ってませんから、今のようなスマホ時代じゃないから、工場用の100万円以上する白黒カメラをなんとか手に入れて、2つつけて研究開発を始めたっていうのがスタートでした。これがその当時の、唯一残っている動画になりますけど、1993年ですね。ちょっとさすがに画像が、古いですけども、よく見ると、先行車、こう、四角い枠で囲んであったり、車線の認識が取れていたり、原理的にリアルタイムで映像が撮れることがこの時代になんとかできるようになってきたということです。大きいコンピューターですけど。それをなんとか量産しようということで、少し時間を巻き上げますけども、1989年に単気筒のエンジンの計測器、そこから今のようなリアルタイムで実車で評価しようってことでやってきました。で、1999年、ここに私、設計のもう2週間で仕様書書いて、1年間、2年間で量産したっていう、今日は喋ると長くなるのでやめますけども、後でそうですね、取材お待ちしてますなんつったら、 来ちゃうかもしれないな。99年に世界で初めてステレオ法による運転支援システム、アクティブドライビングアシストというのを発売しました。限定生産、受注生産、わずか数百台でした。で、私も30代でしたけども、300万以上の高い金だったんですけど、買っちゃいましてね、ユーザーのリストに私の名前が11月登録で出てますけど、これ9月の発売で。そんなことがあって、全然ヒットしません。で、今日は、この辺スーッと行きたいと思うんですけども、いろんな苦労があって、全く売れないものですから、いろんな機能を追加しても、時代もそうですよね。スバルというと四輪駆動とかツーリングワゴンの印象ですから、なんで運転が得意な人にこういう運転支援のシステムが必要なんだ。これは社内の中でも議論が結構ありました。ところがやはり事故を救いたい、環境対応ということになってくると、だんだん ITS とか、ASV という時代になりますから、やっぱり我々が作ってきたステレオのロバスト性というか、そのリアルワールドで強みがあるというのが評価されてくるんですね。で、少しずつ売り続けてました。で、実はここが2010年の5月発売の皆さんご存知のアイサイトっていうのは実はここの車なんですね。ぶつからない車。ぶつからない車。これ初めて、世界で初めてです。それまでは実はぶつかる車なんですね。言い方を変えると。それは世界的なレギュレーションがありましたので、ぶつかるんだけども、それまでにブレーキかけて、前方を見てブレーキかけて、速度を落としなさいと。で、速度を落とすことで、死亡に至るものを軽傷で済むとか、被害軽減をしましょうというのがそれまでの時代でした。で、そこでですね、ところがスバルは2010年にもうぶつからない、本当に止まるという機能を入れたために、これが皆さんご存知のメガヒットになったということになります。少し進めますね。で、今のアイサイトは、先ほどの説明では、時代が時代、CCD という白黒でしたけども、今も CMOS がいっぱい流通してますから、カラーカメラです。で、信号も歩道車も自動車もすべて、リアルタイムに検出しているので、30年前に考えていたコンセプト構想が、今は技術の革新とともに実現しているということになります。はい。で、そうやって鳴り物入りで、ようやく15年売れなかった時代からぶつからないっていうのを思い切って飛び出してやったところ、ここがアイサイトの評価ということになりますけれども、最初に、この前、実は横軸が、何ですか、毎月の売上、毎月の月になってますんで、この左側、ゼロより左側は実は15年前、15年前というか、初代の99年から売れない時代が実は続いてるんですね。で、左側の0点のところがアイサイトぶつからない車バージョン2が出た時になります。で、この縦の棒が、販売台数です。それから、着目していただきたいのは、どちらかというとこの折れ線グラフなんですけれども、これ、横軸が月、2ヶ月ぐらい置きですね。で、パーセント、搭載率になっていて、一番上が 100% になります。だから、同じレガシー売っても何台がアイサイトつけてくださってるかということを示していて、この売れる前の10年ぐらいはですね、5% 以内です。だから右側が軸が出てますけども、右側が0から10、このぐらいですね。一マスが 10% ですから、もう全然横ばいなんですね。で、さて、アイサイトぶつからないコマーシャルやった途端にですね、この折れ線がバーンと立ち上がっていくわけです。で、もう2、3ヶ月経ったらもう 70%、確か、全国で 60%、2ヶ月か3ヶ月で。で、群馬は地元なので 80%、一気に装着率上がったんですね。で、これ当たったのかどうか、私もやってる本人としてとても信じられなくて、営業の人間にこれ、100倍にしたんじゃないのって、なんか、計算間違えたんだよね、なんて言ったら、いやー、合ってんですよ、日渡さんって言われまして。というぐらい、このぶつからないという機能は、一般のお客さんが一番分かりやすい機能だったということになります。やっぱ被害軽減とか、いろんな複雑なこと言っても分からない。これ、マーケティングの強さだったと思うんですけど、ぶつからない自動運転だとかね、そういう単語ってのはやはり分かりやすいですよね。でも一方で自動運転とかって最近言葉が歩いてるのが僕は非常に心配してるんですけども、 自動っていうのはそれは夢のような車だけども、そんな簡単にはいかないということをちょっと後半ではご説明したいと思います。で、まあ、世界的にはもう300万台以上、もうまあ、この辺は飛ばしますけれども、どんどん拡販しています。もうほとんど、まあ、装着率 92% ということで、例えばトヨタさんと一緒に作ってる BRZ とか、あとは軽自動車のダイハツさんみたいなのを除けば、スバルで作ってるのはもうほとんどついてると思ってください。それから、ここは少しだけ触れて、時間がなくなりますのでやりますけども、これはですね、ぶつからない車っていうのは同じじゃないんですね。いろんなカーメーカーのがあります。で、ステレオカメラが赤で、あと他社さんのやつをミリ波レーダー使ってるのを2台並べてます。で、簡単に説明すると、例えば衝突安全が高い点数ですっていうのは、こういう N キャップと言われる、何もないところに障害物を置いたときに止まれるかって評価するんですね。そうすると、どのセンサーでも大体 100% 止まれます。ただ、右上のような、これは自社のコースなんですけども、本当にリアルワールドの木が生えたり、ガードレールがあったりという道だと、レーダー、電波式のようなものを使うとですね、いろんなところに信号が乱反射して、電波が乱反射して、それが嫌だからフィルターをかけて、置いてあるターゲットも実は見えなくなることがあるんです。で、説明、見ただけでちょっと勘弁いただきたいんですけども、アイサイトだけが 100% 止まっていて、他はやっぱり非常に不安定、止まらないこともあるということですね。こういったところで実際の道路で、効いてくる。これは今度は速度が低いところです。他のセンサー群だと、バンパーの先にセンサーがついているので、障害物の距離が取れないんですね。判断しても間に合わない。でも一番上がステレオカメラで、カメラは窓ガラスの上からバンパーより手前に非常に距離が取れる。ですから、バンパーの先までの先についてる物体も検出できるので、低速でもぶつからないができます。はい。ということで、売り出した車のアイサイトの装着されている車で統計を取りますと、死亡事故に至る事故のうち 61% がアイサイトついていることで救われたというのが実証できました。ということで、表彰もいろいろいただきました。で、これですね。で、最後になります。ぶつからない車を発展させて、自動運転の機能もスバルとしては展開しています。2017年には、レボーグで、1回、シンプルな自動運転出した後、オリンピックで右側ですね、一昨年の秋ですけれども、アイサイト X ということで、オリンピックに合わせた自動運転車をもう販売しています。アイサイト X、乗った方もおられるかもしれませんけども、ぜひですね、各ディーラー行ってですね、乗っていただきたいなと思ってます。で、こちらがそうですね。で、申し上げたいのは、自動運転というのは非常に厄介なもので、単純に走ればいいわけじゃないんですね。我々の思想としては、あくまでも普通の交通流で安全を担保する。例えばカメラも広角、いろんなレーダーを使って安全を担保した上で、ドライバーの置き換えができるところだけは自動化するっていう考え方です。ここは非常に思想の中でポイントになると思います。先に自動運転ありきじゃなくて、衝突安全ありきの、その上での機能の開発になります。こちら、その時のアイサイト X の開発の、途中のテストコース映像ですけれども、右側に車が来てるときには、レーダーで監視していて、車線変更しません。これ手離してるのは実験中なのでやってますけども、実際には量産は手離しません。で、車がいなくなると、空いてる車線に車を移動させるっていう機能がついています。これが一例です。はい。今日は長い話になりましたけれども、アイサイト X、ということで、カーフでいただいたということで、これで以上で終わるわけですけども、セーフティー安全ということで、自動車の中では申し上げたように、すべてのお客様が対象ですから、いかに本当の交通流の中で安全に、止まれるか、そういうことを考えなきゃいけないというのがまず第一にあります。その上で自動化するところは、その安全担保の上で自動化の一部を入れていくという考え方で進めています。ということで、長い話になりましたけども、また引き続き、ディスカッションができたら嬉しいです。本日はどうもありがとうございました。以上になります。
The next speaker will be Dr. Hiroaki Kita from Daifuku Corporation. The title is Strategies to Improve Safety of Daifuku. Please start the presentation.
Thank you, Mr. Tanigawa. I'm Hiroaki Kita from Daifuku, Japan. Today, I would like to talk about strategy to improve safety of Daifuku. Now, here is a short outline of Daifuku's business. Daifuku was established in 1937, after over 85 years. We are now one of the leading material handling companies in the world. The capital is about $3 billion. Last fiscal year sales were $4,300 million. Daifuku has 6 core businesses. First, various manufacturing and distribution industries. Second, flat panel display and semiconductor industry in clean room. Third, automotive industry. Fourth, car wash machine. Fifth, airport baggage handling system. Sixth, electronic for information system. Our advantage line in its one-stop support structure, which deal with all kinds of service and operation, including system construction, production, installation, after-sales service for long-term stable operation and replacement. So, please look at those videos. Daifuku has expanded its network worldwide. We currently have 54 affiliate companies in 26 countries and regions, providing a global framework that supports our customers around the world, achieving a non-Japan sales ratio more than 65%, no matter where they are manufactured in the world. We provide high-quality system via local production. This is our Shiga Works, which is Daifuku's mother factory. Within 1.2 million square meter area and more than 3,000 employees are working in 12 factories. This is our safety strategies. As is shown here, we manage safety in 5 phases. Currently, we are reaching from phase 3 to 4. There are 3 points in our transition. First, we have established Safety Promotion Department since 2007 and introduced OSAS management system to implement safety activity. Second, in the wake of a serious accident occurred in 2013, Safety and Health Management Division was established and management takes the lead in promoting safety initiatives. Third, we are developing safety management system not only in Japan but also at affiliate companies as we expand globally. Today, I would like to focus on following 3 strategies highlighted in yellow. First, safety assessor clarification. Second, development of global safety. Third, drive recorder for a company car. We have a company car about 900. We are promoting an acquisition of safety assessor clarification for the purpose of developing safety human resource globally. who have safety knowledge and skill based on global safety standard ISO 1200, fostering a corporate culture as safety is a value, not cost. Personal development, who is capable of design, manufacture, and install a safe product. By increasing the acquisition of safety assess qualification, we have developed many human resources who have the skill to carry out a risk assessment, and we have reduced the risk. As a result, the number of occupational accidents is decreased and there has been no serious accident. Our next target to conduct more in-depth risk assessment and to promote safety officer qualification for management. This is a concrete implement case of risk assessment because the position of the tool bit of 5-phase processing machine was not visible as it hidden by the workplace or jig. The operator had to move closer to the spindle to check if the tool bit would interfere. We conduct a risk assessment, then install small cameras and monitors to clearly make the tool bit visible, thereby reducing the risk of getting caught in the spindle. We are working to achieve zero occupational accident under Central Safety and Health Committee, which cover safety for the entire company. In line with globalization, affiliate companies in Asia have been participating in the committees since 2017. In addition, since more than half of all occupational accidents were occurred by inexperienced workers, we provide a basic safety training to our affiliate companies, focusing on the following two words. First, using maybe to anticipate hazard. Second, preventing human error by pointing and calling. In Japan, we have been providing a safety training center since 2010. And in 2019, our affiliate companies opened 5 safety training centers, 2 locations in China, 1 in Indonesia, North America, and South Korea. We are working to expand our hazard awareness training globally. By sharing safety initiative and safety information, various initiatives have been developed globally. Safety awareness has increased on a global basis and signs decrease have been seen since 2020. Next strategy we have in mind is to simulate a near-miss activity or future prevention to ensure the safety and security of our employees. We are taking various measures to prevent a traffic accident as well. We take proactive approach by dividing it into 4 categories. First, in the skill and knowledge, we conduct a 13 tests to determine whether an employee is eligible for a business drive. Unless they reach our criteria, they are not allowed to drive a company car. Secondly, safety training. We have recruited a drive instructor as a specialized trainer to provide regular training to improve drivers' safety, awareness and hazard sensitivity. Thirdly, as for administrative measures, we clearly define our standard and rule, such as prohibiting more than 2-hour driving. Fourthly, physical measures. We define safety device which must be installed in our company car. In particular, we believe that drive recorder with a telematics function is very effective in preventing accident. When we installed the drive recorder in our car for the first time back in 2012, it was standalone type. We need to go through each SD card for data analysis, and we spend many time. Currently, all cars are equipped with a cloud-based drive recorder, which provides real-time information for the operation status. When a dangerous driving is detected, such as sudden start, sudden braking, swerving, and overspeed, a warning alert is released to notify a driver, and an alert email is sent to driver's manager at the same time. In addition, this cloud-based system is capable of outputting various data, such as speed, operation time, location, which are used for quantitative analysis to help prevent accident. Also, from now, we are sequentially installed a drive recorder, which will transmit image of inside of the car to prevent distracted driving, so that we can provide accurate guidance and countermeasure. As it's shown in the graph, our traffic accidents have reduced dramatically in 2020 compared to previous year. In this year, we expect to see more reduction as 360-degree drive recorder has introduced. We are determined to aim zero accident using 3 core measures: drive recorder, safety device, and driving training for the purpose of our employees' safety and security. Finally, an accident very often occurs because we tend to close it out by implementing an easy and quick preventive measure. Education and training are necessary and important for safety resilience, but they aren't providing the desired or expected outcome. We need to change our way of thinking to raise the safety awareness instead of implementing an easy and quick measure for a superficial cause. It is necessary to establish an effective system to institute true preventive measures by passing the actual root cause of the accident. Our aim is to create the circumstance where we all behave safety a manner. Safety is manner. Thank you for your time today. Be safe.
The next speaker will be Dr. Hisashi Ichijo from Toyota Industries Corporation. The title is AI Teams Logistics. Please start the presentation.
Good afternoon, everyone. My name is Hisashi Ichijo of Toyota Industries Corporation. I am Hisashi Ichijo from Toyota Industries Corporation. I would like to thank everyone involved for giving me the opportunity to give this valuable presentation. I am in charge of R&D at Toyota LNF Company, and I would like to talk about my contribution to Vision Zero from my perspective under the title of AI Team Logistics. Today, we would like to introduce our efforts in the logistics industry with a focus on worker safety, health, and a better working environment, from company introductions and case studies to the vision of logistics toward 2030, automation of logistics. I would like to introduce our company's initiatives in the logistics industry, focusing on worker safety, health, and a better working environment. First, an introduction of the company. This video introduces Toyota Industries Corporation from its origins to the present. Please take a look this video.
Toyota Industries Corporation. TICO, the origin of the Toyota Group. TICO has grown as a global organization by overcoming a lot of difficulties. TICO continues to look toward the future with the spirit of monozukuri, excellence in manufacturing. The power that drives this quest has roots in Sakichi Toyota's spirit of research and creativity, which has been continuously passed down to each generation.
From this slide, I would like to introduce our company. In 1926, Sakichi Toyota, the founder of the company, founded the company to enrich society and people's lives. Sakichi Toyota invented the automatic loom to enrich society and people's lives, and the company was founded to sell the loom and make it available to as many people as possible. Later, looking 50 years into the future, Sakichi Toyota established its automobile department ahead of its competitors. Then, in 1937, we spun off our automotive division and founded Toyota Motor Corporation, the predecessor of today's Toyota Motor Corporation. In the 92 years since our founding, we have continued to take on the challenges of various industries and business categories as a manufacturer. This is our company motto. It is the spirit of our founding that has been passed down from generation to generation. It is the starting point of our company. It is the basis on which all employees of the TICO Group base their decisions and actions. This slide shows our three main businesses. The first is textile machinery, a business that originated in the group. Currently, air-jet looms, which use the power of air to send weft yarns flying, are the mainstream. We have a 38% share of the global market. 2019 information. The second is compressors for car air conditioners. This business currently accounts for 36% of our global sales share. This means that more than 1 out of every 3 cars sold in the world today is equipped with our compressors. The third is forklifts. Under the brand name of Toyota LNF. We are developing and marketing logistics equipment and systems used in factories and warehouses under the brand name Toyota LNF. LNF stands for Logistics and Forklift Trucks, a brand name for logistics equipment and logistics systems used in factories and warehouses. LNF stands for Logistics and Forklift. LNF currently holds approximately 20% of the world market share and over 50% of the domestic market share. We are sure that many of you are familiar with our products. We would like to take this opportunity to thank you for your patronage. Here is a chronology. The loom was developed by Sakichi Toyota in 1890. The loom then underwent various evolutions, and in 1933 and 1956, the company began producing forklifts. Please watch a video about the production of forklift trucks here.
Aiming to expand the use of the S-type gasoline engine, in 1955, we started the development of forklift trucks as one of the cornerstones of our business diversification. Having completed a prototype and practical tests, we launched the production of the model LA lift truck in 1956. Although a latecomer during initial phases of the business, we had created a sound foundation as a lift truck manufacturer by cost reduction, performance improvement, and increasing our lineup in the range of 1 to 3 ton models.
Here is the sales ratio by business segment. The company's total sales will exceed 2 trillion yen in 2021, with industrial vehicles, of which the Toyota LNF company is in charge, accounting for 67.6% of the total. This slide shows our main business domains. Our products and solutions are used at ports and airports, where goods enter, and in factories and distribution warehouses, where a variety of conveyors and forklifts are in action day and night. Next, we introduce Toyota Industries Corporation's commitment to worker safety, health, and a better working environment. First, worker safety. Industrial accidents have been on a slight upward trend over the past 5 years, while fatal accidents have remained almost unchanged. An analysis of accidents by cause shows that 80% of all accidents are caused by being caught in a machine stand, rear-end collision, fall, and collision. In order to eliminate accidents caused by these causes, we developed a system using artificial intelligence last year. Traditionally, we have focused our technology development efforts on safety features. We have long offered multiple safety features, such as rear wheel lock control, mass tilt control to prevent falling down, and so on. And they have been well received by our customers. And we launched Smart Eye Sensor System Plus, called SENS Plus in 2021 as an advanced safety assist function. AI camera on the forklift detects a person in the specified area, warn the operator, and control travel speed. This is the industry's first safety support system. Please see the introduction video. Next, let me introduce activities for zero emission. We have traditionally worked on the development of products with high environmental performance, and began mass production of electric forklift trucks in 1987 and fuel cell forklift trucks in 2016. We believe that the need for electric forklifts grow for a zero-emission, carbon-neutral society. Now we are strengthening our development of high-performance electric forklift trucks that can replace engine forklift trucks. Fuel cell forklift trucks utilize the same cells used in Toyota's Mirai. By packaging all the functional components into a structure equivalent to a conventional lead-acid battery, it is possible to replace the power unit on the same truck platform. The third is the zero-complaint approach. The logistics industry is generally considered to be a tough and dangerous place to work. Our goal is to free people from such work through automation technology and to realize a safe and comfortable work environment. This is the image of the logistics system we are aiming for. Many automated equipment inside and outside work together efficiently. Our development direction is the case to realize it. Especially, the algorithms to optimally control a large number of these devices will be of great importance in the future. This is the autonomous forklift we developed. It can do difficult tasks such as loading and unloading of trucks with high accuracy. This is an automated airport baggage handling system we developed. By automating hard tasks such as loading baggage into containers and transferring it with towing tractors, we contribute to improving the working environment of ground handling operation. Lastly, let me introduce our vision for 2030. Please see our concept movie of future warehouse logistics. Various automated devices, logistics drones, communicate with each other and are optimally controlled by AI. And no waste, no muda, ultimate logistics will be realized. We will continue to develop technologies to realize such a world. This is all for my presentation. Thank you for your attention.
The next speaker will be Dr. Stuart Hughes from Mercedes-AMG Petronas Formula One Teams. Also, he is Vice President for Institution of Occupational Safety and Health, IOSH. The title is Creating Sustainable Resilience in OSH. Please start the presentation.
Die Devise der letzten Stunden: Überleben, nichts mehr riskieren, ankommen.
Hello all, welcome to you wherever you are in the world. My name is Judy Hughes, and I'm the Head of Health and Safety for Mercedes-AMG Petronas Formula One team. I believe that the provision of a safe and healthy work environment is a fundamental human right. How and where work is undertaken must provide employees with the ability to perform consistently at their best. And I know that human performance is at the epicenter of delivering sustainable resilience in occupational safety and health. Over the next 20 minutes, I'm going to provide you with some context of the team, our operating environment, and those challenges. And I'll talk to you about what health and safety is and what it means to the team, how it's seen as a critical part of our high performance ecosystem, and I'll share with you some of the lessons that I've learned over the last 6 years with the team. I've enlisted the help of some video content to set the context and so you can hear from some of our leaders. So with that in mind, let's take a tour of the factory. I hope you enjoy the flight.
We'll start our tour in the Silverados Lounge. You'll see the car there in its black livery, representing diversity and inclusion in motorsport and throughout the team, something that we've been championing for the last 2 years. This space is used to host our partners and for some training facilities. You'll also see that we're very proud of our heritage and have cars in numerous different places around the site. The one suspended from the ceiling is particularly one of my favourites. As we come out and across the site, you'll see that we are set up as a campus style. We'll make our way over to main reception area. The site holds over 1,000 people working 24/7. In reception you'll see another one of our trophy cabinets. We celebrate our success. You'll see here the screen that all of our employees sign to acknowledge their contribution to that year's car, and whenever you walk into reception and see a car, it's a very good reminder of what we're all pulling together for. As we come into the main factory, we'll take you into our race support room. Our race support room is how we connect our engineers that are based back in the UK to trackside. They're in constant communication. They work at the same time as the race, so if we're in Australia, the men and women in the UK are on Australian time. They can talk to the pit wall, to all of our crews trackside, and relay crucial information across all of the weekend. We'll take a trip downstairs into the heart of the factory. You'll see in front of you one of our composite laminates areas, and we'll head now into inspection. Inspection's a crucial element, making sure that the components are correct size and spec for against the drawings, and making sure that they are fit to go onto the car. We'll come in now to our new race bays. It's also a space where we're able to gather all of the team to deliver key team messages and also race debriefs. Less used during COVID for obvious reasons, but we're looking forward to getting back to using this space in the season ahead. From the race base, we'll take you into our main machine shop. The CNC machines in here will machine aluminium, titanium. We'll be making gears and gearbox components and other metallic elements for the car. The engine's not made on our site here, that's made at our sister site in Brixworth, but the machine shop's obviously a crucial area of our performance, and runs 24/7. We'll quickly take a little flight into our gearbox department. Within the gearbox we screen all of the gearboxes that come back to make sure that there's no damage and that they are fit to run the kilometres that they are scheduled to. That gives you an insight into some of our facilities within our main operating environment. The reality of life in the factory is that we're a manufacturing operation with many of the same occupational safety and health challenges as any manufacturing environment. We have over 1,000 people on site, We run a 24/7 operation across various shifts with a mix of knowledge and skilled workers. Our tight deadlines, challenging cost cap regulations and need for exceptional reliability all add to a mix of factors that push and pull against our occupational safety and health direct objectives. And that's the factory. Now let's take a look at how trackside operates.
Hi, my name's Carl Fanson and I'm the head of logistics for Mercedes-AMG Petronas. Just going to give you a run through of what we would typically bring to a European race and the offices that we work out of and some of the workshops. So this is our new race truck setup for 2019. We've got 2 Arctic trailers with different pods spread across the top which build the engineering office upstairs. Downstairs we've got different workshops for different departments to be working in. Go ahead and have a look. So this is our live stores area. It's where our parts plan sits, and then we've got the chief mechanic that sit at the back. Carry all different sorts of equipment in these cabinets. Anything from different car parts that we're running to resealable bags and stationery. We carry everything completely self-sufficient. Through to here, we've got our electronics area where the lads build the steering wheels, work on wiring harnesses. So this is our Truckee Workshop. This is where we'll be working on different wheel guns, brake fans, changing adapters for different cooling specs that we'll be running. Through here we've got our hydraulics workshop with filtered air in, filtered air out. That's where the lads will be working on the clutches and all different hydraulic parts. This is our ERS work clean room. So this would be the test bed where Elliot would be working on the ERS packs, servicing, repairs, general maintenance. So this is the helmet locker room. All the mechanics have their own locker, pit stop boots, pit stop overalls, straight in here. So everything's been laundered, washed, and all put back in here ready for us to use on Sunday morning. So welcome to our tyre area. This is where we prep all the tyres. It's a great area for them really. It's big enough to be working out of, and you're guaranteed space, whereas in the garage, different locations you could have different size working area. So this is what we class as one of our pop-up trailers. Downstairs we have the fuel lab in the back, we have a consumable area and a driver kit area. Upstairs we have a doctor's surgery with our physio and our team doctor. Then we have an IT suite, our McLaren electronics area, and then we also have a hot desk in office for 14 people at the back. So this is our Petronas mobile fuel lab. Nasri, busy away analysing fuel, oils, any different fluids that we would run in the vehicles. You've got a maximum of 8.5 metres width that we're allowed from FOM, and the length of a trailer, 13 metres, and then we're 7.1 metres tall over 2 stories. We seem to use every inch of space that's allowed to us from FOM, so we've got engineers upstairs and then we have technicians working downstairs.
We've got about 24 people up here. A lot of the engineers and the drivers sit here on this central table, and then you've also got people keeping an eye on the engines during running, and then on this side we've got people who are keeping an eye on the chassis systems, checking that they're running okay. And some people have got a seat here where they can keep an eye on the car during the sessions, and also a seat on this main table where they're required to be working more closely with the drivers. Essentially every morning, even on the setup day, we'll have a big meeting involving all the engineers and the drivers. And that's sort of looking at the plan for the weekend, for instance, and what the main concerns are, what we need to be focused on, and what objectives we've got for the weekend. And that carries on really with each day, where you break it down into more bite-sized chunks of what we're actually worried about on a Friday, on a Saturday, on a Sunday. So that's 4 big sort of preparation meetings. And then after each session, so after P1, after P2, we'll have debriefs with the drivers where they will give us their opinions on the car, tell us what the main problems are. But it also gives a chance for everyone else to ask them any particular questions they've got, or if there's any things that people are particularly interested in, the drivers can give that feedback, and that's all recorded as well, so people back home can listen to it, and we've got a record of it for future years as well.
Hi, my name is Ron Meadows. I'm the sporting director for the Mercedes-AMG Petronas F1 team. We're going to do a quick tour around the garage and I'll show you which different departments we have and how we build a garage. Everything you'll see, we have mainly 6 sets of it because we do lots of sea freight for the flyaway races. This is our gearbox department. 2 gearboxes are ready. This one's being prepared as a spare. The 2 Friday boxes are already on the cars. These are the race gearboxes ready to go. We also have some more spares which are placed in the trucks, but in a perfect world we'll just use the Friday ones, the practice 1, practice 2, install the race ones which need to do 6 events, and then we're allowed to recycle. And this area is called Wing World. We have the front wings and the rear wings, which is being built by 2 technicians. An awful lot of work goes on here because changes during the weekend from downforce levels. And here is a rig where we set up the wing heights because there's a certain box the wing needs to be in for legality. So when it fits to the car, we know that it's within 1.5, 2 millimeters, and then we shim it to suit here to get the height correct for the regulations. During the 2019 season, this has been the busiest department for sure with the new wings. This is our power unit department, and as you can see, we're not allowed in here. It's all secret squirrel stuff going on. The battery department is built into the trucks, but this is the main part of the engine is here. As you can see, it takes up a fair percentage of the garage, but it takes up a fair percentage of the car as well. So we're currently stood at the front of the garage. The cars are about finished. In the next 10 or 15 minutes, they'll be going up to the FI weighbridge for a check for legality. All in all, it takes about 12 to 14 hours of about 14, 16 people to build the car from a bare chassis. And when we're on flyaways, it's normally 2 working days between getting the freight and having the car finished. So this is the engineer's centre station. So during sessions, you'll have a PU engineer, a rackman controls engineer. You'll also have a performance engineer and a lead race engineer. And at the far side you will see is where Toto sits. Lots of footage with Toto sat here, sometimes giving it this and sometimes giving it this. So it a lot depends on results and how we're getting on during the weekend.
Across both the factory and trackside, our constant is pressure. We have high stakes. We need to win, and we always have to perform. Our performance is analysed on TV in front of millions for 23 races. There's 23 weekends in the year where we are under high pressure and high scrutiny. The value of this, though, is that if we make a mistake or if there is an error, we have an immediate opportunity to put that right, to learn from our mistakes and to improve. We also have uncertainty. When are the parts arriving, changing demands, delays, information missing, updates coming, they all add to the pressure. And we have very small margins. The races don't move, so everything is on short lead times. There's no fat in the system, so if it goes wrong, it's about how quickly we recover. And the changes when they happen are fast. It might be new aero understanding, changes in priorities, or modification of parts. These all add to the pressure that we operate under. And then we have judgment. Feedback from our events, so understanding through tough love where we've gone wrong, how we can do things better and what we're going to do to make those improvements. We have engineering notes from the events which can be critical, but the criticality of those is designed to drive performance improvement. And all of this equals pressure, and we have to learn to be comfortable being uncomfortable. Tough love is used to honestly feedback, to acknowledge our failures and to improve after each event and at the end of each season to start again, better, prepared and ready to win. So here's a little clip of a high pressure situation at the track.
So box, 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 box. and box, box, box. So you're following Lewis C. Okay, don't make me lose time then.
When they feel the need to take that risk of a double stack.
Well, they are double stacking because Bottas is coming into the pits as well, and he's waiting, and they've got this absolutely spot on. Valtteri Bottas didn't have to slow down any more than he was required to with the 80 kilometres an hour speed limit. That was proper perfection. Just when one went out, the other one's ready to come back in again. It was like a production line.
And the choreography of that is sensational.
I've had a go in a practice environment at pit stops, and I can confirm it's nowhere near as easy as the men and women on the team make it look. So how does our occupational safety and health interact with all of this fast-paced, high-pressured work? Well, we are working towards creating sustainable resilience in OSH, whereby occupational safety and health is a fundamental part of our high-performance ecosystem, helping to drive and sustain our performance on and off the track. How this is seen and felt through the team is alignment of OSH with our purpose, mission, vision, values and ethos. This alignment is a crucial step. OSH Performance delivers best in class, providing the team with a competitive advantage. It's seen as business as usual and not a bolt-on activity. Our leadership role model safety, recognising its value and rewarding people where they role model safety across the team. OSH is delivered as we set out. There isn't a gap between what we imagine being done and what really happens, and we work continuously to learn and improve. Occupational safety and health is aligned with our reporting culture, with our see it, say it, fix it mindset, and ownership is felt at every level of the team. We have a very clear intent. And leading with intent is our leadership model, and OSH is aligned to this with its own statement of intent that clearly maps out what we are working to achieve, and more importantly, why. And here we talk about a 1% safer mindset. That's focusing on continuous improvement. We make sure that it's very clear that every single member of the team has ownership of occupational safety and health, and we commit to protecting each other. And we use that through our see it, say it, fix it framework. Our leadership also have a big part to play in making sure that our occupational safety and health culture is visible and clearly communicated to all team members. Our safety steering committee is made up of senior leaders across the scope of the team and holds 6 core areas of focus in driving sustainable resilience in OSH. First of all, we have well-being. We focus on well-being because we know that caring makes the car go faster. We also have personal responsibility, where we commit to looking after ourselves and each other. Competence, where we provide occupational safety and health competence at all levels that is appropriate and proportionate to risk exposure. Our safe workplace, we're committed to sensible and proportionate risk management. Our efforts are targeted to our significant risks, and we know our risk tolerance. Culture, occupational safety and health is part of our culture rather than a standalone culture. And our leadership is visible, and our commitment to sustainable resilience in OSH is clearly communicated to everyone in the team. I mentioned earlier, see it, say it, fix it. And this is our mindset to creating a culture where it is safe to speak up without fear. This is vital for occupational safety and health, but it's also vital for reliability, quality, and overall performance. And the alignment of these things helps us to bring occupational safety and health into part of our culture. We ask our employees to tell us what they have seen, why it's important, and what they have done to resolve it, because they are empowered to do so. But where they need support to fix it, there are mechanisms to ensure they receive the help they require to do so. We have also removed the friction in our reporting process, and over 2/3 of our reporting now comes into the system via WhatsApp. But what's really powerful isn't just me telling the organisation about the power of speaking up. It's not just me speaking about the value of this mindset, but actually this coming from our leader. Over to Toto.
We created a motto within the team in order to discover all our weaknesses. That is, see it, say it, fix it. We encourage juniors to report upwards and report about problems or areas we can improve. You need to achieve a safe environment. If the leaders are able to admit their own shortcomings, suddenly you create that culture where everybody is able to admit that next time you can do better, and you mustn't blame the person, you blame the problem.
No, that's really powerful. And if you can do that and have people consistently do it, on a day-to-day basis, that will be such a catalyst for innovation in any business.
In addition to our focus on safety and occupational health is our focus on human performance and well-being. Peak, our well-being program, builds on our focus of car performance and operational performance to focus in on human performance. How do our employees achieve and sustain optimal performance? Well, Peak focuses on three core elements: the physical, mental and recovery, and all are underpinned by an environment that is psychologically safe. This is again an area where competitive advantage can be achieved. You will see each element has 5 focused areas designed to deliver optimal human performance. Now in the physical, we focus on cardiorespiratory endurance, body composition, muscular strength, muscular endurance and flexibility. In recovery, we talk to nutrition, hydration, sleep, optimal recovery and intentional rest. And in the mental area, we focus on cognitive function, attentional control, emotional regulation, positive outlook and self-awareness. And all of these combined help us to help our employees achieve optimal human performance. To close out, I'd like to share some learning with you and areas that you can take away to consider in your own organisations. 1. Where does occupational safety and health sit within your organisation, and is this optimal for you? My occupational safety and health team sits within HR. I report directly into the Chief People Officer and have a direct line to the Management Committee as a result. The benefits of this are that we are independent of operational pressures. We're viewed as neutral by the team. We gain great insights as to the stakeholder pressures throughout the organisation brought to us by our HR business partners. HR and health and safety are able to align on objectives and maximise stakeholder value. And we're also able to deliver an aligned agenda to support the delivery of key programs and messages into the team. 2. Does occupational safety and health speak the same language as the rest of your organisation? When I joined the team, it became clear there was already a language around failure for on-car activity and clearly defined definitions for each. Therefore, it was easy to harmonise how we spoke about failure in occupational safety and health and align with on-car terminology that was already familiar to the team. This has really helped to ease the understanding of occupational safety and health issues and their severity. 3. Is there a clear why for occupational safety and health in your organisation? All employees know they own an obligation to bring performance to the car. We call it owning your 10th of a second. Wherever you work, whatever your role, you contribute to on-track performance, and occupational safety and health is no different. In fact, it's an area where every employee has the opportunity to make a difference, and we communicate that through our intent that is aligned to our mission, vision, values, and our purpose. That alignment is critical because aligning occupational safety and health to the intrinsic purpose, mission and vision of the team and aligning our values with occupational safety and health helps everybody understand what it is that we set out to achieve. And finally, is your messaging understood and reinforced by your leadership? This is critical. From the very top of the team, the performance value of occupational safety and health is understood, and it's also reinforced from TOTO in our occupational safety and health policy and staff handbook to key messages that are reinforced during TV interviews for all of our employees to see, to the all-team staff briefing where our COO Rob Thomas talks to the whole team about our OSH performance, the value of our wellbeing programme, and thanks our employees for their engagement in See It, Say It, Fix It. I'd like to take this opportunity to say thank you for the opportunity to come and present to you today. It's a real shame not to be in the room with you all and to have experienced what will have been a truly powerful event together. I hope that you've enjoyed this presentation, that you leave it thinking about the alignment of occupational safety and health within your own organisations and its value in contributing to you achieving your purpose, mission and vision.
Okay, the speaker will be Dr. Marvin Chang from National Institute for Occupation Safety and Health. The title is Understanding Safety and Trust of Human-Robot Interaction. Okay, are you ready?
Yes.
Okay, please start your presentations.
Hi, everyone. My name is Marvin Cheng. The topic that I'd like to present today is understanding safety and trust of human-robot interaction. In NIOSH USA, we focus on investigating the prevention of potential injuries in different working environments. As a rapid growth of robot applications in various workspaces, it is necessary to understand the concerns of safety and trust of human workers interacting with robotic devices. The research activities in this presentation adopted different techniques of machine vision to acquire the movements of both robots and human workers in the same workspace. The rapid growth of the industrial applications using both mobile and collaborative robots has generated new safety concerns in the workspaces. In these environments, physical and movement characteristics of robotic devices may impact workers' behavior and safety protocols. Therefore, worker trust in robotics needs to be improved, and the interaction model needs to be integrated in the robotic operations. So far, many standards has been published to regulate the safety requirements in terms of the behavior of physical robots, including the integration of devices in the environment and the operation and programming of the robots. This slide lists several important standards related to robots of both collaborative and mobile robots. Currently, the R15.08 subcommittee in the Association for Advancing Automation is working on the second part and the third part of the safety standards used for the mobile robot applications. As a research at NIOSH and the assistant coordinator of the Center for Occupational Robotic Research, I'd like to talk a little bit about the recent scope of the center. The mission of the center is to provide scientific leadership to guide the development and the use of occupational robots that enhance worker safety, health, and well-being. Currently at NIOSH, we have several labs related to different emulated workspaces. The core lab also has an emulated workspace with 7 robots, a motion acquisition system, and 4 depth cameras. We can also use a virtual reality lab to emulate different operations and different interactions between the human workers and the robotic devices. As to the center scope, the center aims to address traditional industrial robots as well as evolving robotic applications, including collaborative robots, mobile and coexisting robots, wearable robotics, remotely controlled and autonomous ground and aerial vehicles, and the future robots involving advanced artificial intelligence. For the research activities related to mobile robots at core, the typical sensors for mobile robots used for machine vision might include RGB cameras, depth cameras, LiDAR, motion acquisition devices, and various optical sensors or arrays. Those sensors can be used for specific machines in different working environments. The sensors might need to be calibrated based on on-site situations. For example, the color of the same mechanical components can be very different indoor or outdoor while being acquired by an RGB camera. Calibration is therefore required under different light conditions. Different sensors can then be used for targeted tasks. For example, the pictures shown in this slide demonstrates the detection of moving humans by using LiDAR. In this example, the fixed structures can be registered in a map beforehand, and the robot can isolate the moving workers on the map. As you can see over here, the green ones are the fixed structures, and the blue ones are the moving subjects on the map. With STEP's camera, the skeletal information of the workers in the same workspace can be acquired as well. Such information allows the mobile robot to travel around the human workers actively, and any factor of the robot can also avoid unintended contacts while performing designated tasks. With the assistance of the vision sensors, the robot can certainly avoid unintended contacts and potential injuries in the collaborative environment. In NIOSH, we are also investigating the safety and trust issues in human-robot interaction. At this moment, the safety standards have not specified for the interaction between mobile robot and human workers with varying sizes and behaviors. We would like to know the psychological responses of human workers while they need to work with robots for different speeds, sizes, and movements. At NIOSH, we have developed several operation themes using our virtual reality lab. With the help of the motion acquisition system and depth cameras, we can detect the movements of human subjects in different virtual environments. The physical properties of the virtual robots in these themes can also be adjusted to record the responses of human subjects. Then we can determine the concerns of both safety and trust in those interactions. The pictures and videos here demonstrates the synthesized virtual scenes in our lab. We would also like to enable the robot to actively avoid unexpected contact with human workers in the multi-worker, multi-robot workspace to ensure the robot can actively avoid potential contact. A motion prediction model has been developed using machine learning and NIOSH. Let's talk about the development of the model. Unfortunately, human workers' motions can be difficult to predict due to several reasons. Different body sizes, various moving speed, sudden poses, distractions, and inconsistent moving durations caused by age. All these conditions can greatly distort the expected outcome if the acquired motion information is presented in terms of time series data. So, to reduce the inconsistency explained in the previous slide, a different representation of the data need to be used for motion prediction. For the arm motions shown here, we used the angle to angle plus. In this plus, the x-axis is the elbow movements and the y-axis is the shoulder movements. It is clear that the trajectories now form spatial patterns for the selected motions. To ensure the patterns can be good candidates for motion identification, we also verify the self-similarity of the selected motions. To ensure the similarity, we have taken multiple trials of the same motions from different human subjects. It is clear that the patterns of the selected motions can be distinguished. The results of the 3 selected motions also shown on this slide, and you can see they are identical themselves. Once the motion were acquired from our testing subjects, a deep learning method was applied to develop the motion recognition model. For the 3 selected motions, we totally collect around 700 sets of data from testing subjects. The data was then used to train the motion recognition model. Once the model is built, the acquired motion, the required time for motion recognition is around 1.2 seconds by using an Intel i7 processor. This is the data that we run our estimation of motion identification. However, it might not be useful to recognize the type of completed motion Therefore, we have used part of the acquired motion to build a motion prediction model for these selected motions. With 33% of the acquired motion, we can still successfully determine the type of an ongoing motion. This information can then be fed to the mobile robot for collision avoidance while a human worker is existing in a shared workspace. So as the result you can see over here, with 33% of the data, performed data, we can still have around 97% of successful estimation rate. To ensure the collision-free operations, a mobile robot has two different path planning schedules. The first one shown in this slide is the path planning of the end effector from the result of the motion prediction model introduced in the previous slides. We can synthesize the spatial zones where the robot should not enter, as you can see the green squares over here. Once these zones are tagged, three-path planning method can be applied to avoid unexpected contact, so the trajectories can be synthesized in a 3D space. The other type of the path planning is a 2D movements of the mobile robot in the workspace. In NIOSH, we have applied different search method to optimize the moving trajectories of the robot in the lab area. This slide shows the workflow of the overall operation of the mobile robot in our research lab. We are now working on integrating individual parts into a physical mobile robot system. Currently, we can simulate the whole system on an emulated platform. So we are working on the physical implementation to the robotic systems. So for future robots, with our investigation and research activities, we believe the robotic system in the future workspace can be safer and more user-friendly. Future robots will utilize artificial intelligence technologies, and use of robots will extend to sophisticated service and managerial tasks. Adoption of this type of robots may change the landscape of labor and the workplace environment in the future. That's my presentation today. Thank you very much.
Okay, thank you. Also, we are conducting the same research as our center. So, and it's very informative. So, are there any comments or questions? So, from me, we using AI in human behavior. So in utilizing AI, so there is a debate as to whether AI itself is safe or not. So what do you think about these points?
Well, of course, we hope the AI can be safe. However, sometimes it cannot be always safe because the training model is not well established. So that is one other aspect our institute is working on. We are working on the ethics and working on safety. So at this moment, we are applying different kind of safety standards to fulfill the concerns of worker safety. But for AI, those things need to be integrated. At this moment, we are trying to write into the rules by using the motion recognition. But in the future, we hope we can have a more efficient way to integrate everything all together. But at this moment, I would say it's safe, but not 100% we can guarantee it's safe.
Okay, thank you. Thank you, so Dr. Chance. Okay, next, I'll check next presentation. Thank you. So, okay, next presentation will be Dr. Aaron Preza from FedEx. The title is Autonomous Vehicle and Robots at FedEx. please start your presentation.
Okay, and let me share my screen.
Oh, no. Okay. Okay.
Okay. Well, thank you for having me today for the summit. And I'm very happy to go after Dr. Cheng because he's very much set up of as autonomous vehicles and robots move out of the lab and out of government research, us end users, us businesses that are going to use that technology are very much now starting to see what is possible with this technology and what are some still of the limitations that we have to work through. So just to give an idea of FedEx is a global company. We operate all around the globe. We are four separate companies. The Express company is the one I report to, and we are the aircraft side of the company. We have over 679 aircraft, and we service 650 airports around the globe. And so we service the world through the Express company. Here in the United States, we have our FedEx Ground, which is a trucking network. It is actually one of the largest trucking networks in the world. And also our FedEx Freight team operates one of the largest less than truckload operations in the world as well. So we have numerous trucks as well, and that plays into autonomous vehicles as well, and we'll talk about that in a little bit. And then finally is our FedEx Logistics Group, which does our warehousing and some specialty shipping. But because they do warehousing, they are very much using robots inside those warehouses to process orders and get them out faster. So let's talk about just some of the different types of autonomous vehicles and robots we have within the FedEx network. Those top photos are robots that we use inside what we call the four walls of FedEx, inside our own internal operations. So these are the robots that are interacting on a very regular basis with our team members across the globe, anywhere from a small robot that can move a cart around with packages on it, to an autonomous tugger, to even a small robot that's equipped with scanning equipment to go through our warehouses with RFID readers to scan the inventory of the warehouse through RFID tags. And so the robot is just going up and down the aisles, scanning that product in. The bottom photos are our autonomous vehicles and even robots that interact with the public. These are the vehicles that actually are outside the four walls of FedEx, from our Neuro unit that can actually drive on city streets and deliver packages to our customers, to Roxo, our sidewalk robot that can also deliver packages, but are just on a smaller scale than Neuro, and it does go on mainly on sidewalks, to our autonomous trucking fleet that is now actually active here in the United States of actually moving. We're doing truck runs autonomously between Dallas and Houston in the state of Texas. So these are the three focus areas that my team works on within FedEx, and that's the autonomous mobile robots, AMRs, and these operate within inside the four walls, as I mentioned before. And there are numerous types of robots in this area. And this is going to be a very critical point for FedEx going forward, as well as many other companies. Our goal for these types of robots is matching the right robot to the right use case. Sometimes I just need a robot that can move one package across the warehouse. And so that's going to be a very small robot. But at that same time, that robot, as it's moving across our facility, might come across one of our autonomous tuggers that's bringing in a much bigger, numerous packages or big packages. So now we have this issue of we have a small robot that might be made by one manufacturer and a big robot that might be made for another manufacturer. And our issue now is, how do those two robots communicate with each other? Of, I'm going to go this way, you're going to go that way. Is that an eye in the sky management system that they're made by two different manufacturers? Were they coded in the same way? Are their maps of the facility the same? And this is where the idea of interoperability is becoming a much bigger issue, is we need to build in ways that these robots can actually, lack of a better term, talk to each other through some kind of interface so that they can complete their mission while they share the same space. The next area is our last mile robots, like Roxo and Neuro that I showed you earlier. And now where we get into some issues that we're exploring now is, how do these operate in a residential area versus a commercial area? Those should be the same, but sometimes there's nuances. Some commercial areas don't have sidewalks. How is Roxo, the robot pictured here, going to be able to transverse an area that might not have sidewalks? And that's what it was designed for. Going into the next point, sidewalks versus streets. Sidewalks, you're going to be interacting with pedestrians. If your autonomous vehicle or autonomous robot is on the street, it could be interacting with vehicles, cyclists, numerous other types of items. And how do we program those where they can work seamlessly for us, where they can work in these numerous different types of diverse environments? And then also in this area is the regulatory and international standards. Dr. Cheng brought up some excellent standards that are already out there, but how do we build a last mile robot that we can deploy here in the United States, in Japan, in France? How can that same robot be used in numerous locations, not only in the same country, but within this across the globe? And then finally, our autonomous trucks. We are partnered with Aurora here in the United States. As I stated earlier, we are testing currently in the state of Texas. But even this has regulatory issues. And how do we address those? Is that a state by state basis? Is that a national? If it's national, how do we do trucking between the United States, Mexico, and Canada? Can an autonomous truck cross international borders? What would that look like? So these are some of the questions we're exploring on our side. And we're really looking for partners to help us explore these, because it's not just a FedEx issue. So what are our focus areas going forward for a company like FedEx? Very much AMR interoperability is very much top of our list, because we are going to continue to deploy multiple different robots into our facilities. What is the international robot standards looking like? Can we have common robot standards across the globe so we can actually deploy those same robots over and over again? What does the regulations look at the local, state, and federal level, regardless if that's the United States or Canada or Japan or a country in Europe? And is there ways we could form partnerships of not only manufacturers of these types of robots and autonomous vehicles, but even the end users? A partnership of a bunch of end users can be very powerful in getting past some of these other things like standards and regulations, of having a single voice almost that can point where we need to go in these areas. So as I mentioned, interoperability is a must. We have more and more robots entering our facilities every day, and I can't always buy from the same manufacturers. So these robots might be doing the same tasks in a facility, or they might be doing different tasks. But the one thing that's in common is they are sharing the same space. So just like as in NIOSH's lab of all the work that they're doing there, picture multiple robots in the same type of facility, but how do they coordinate and work with each other like humans do? And not all robots are traditional logistics robots. We are actually using some robots within the logistics community that were originally designed for manufacturing or other types. But how do we integrate those into a logistics operation when we find that they actually have a purpose and use case within a brand new industry that maybe the manufacturer never really thought of, but they actually did create a robot that does address a use case in those industries. And then finally, this is not only a robot-to-robot communication issue, but also what are all the other supporting systems are going to look like? Does the robot, it could be a mobile robot that talks to an arm. It could be a mobile robot that needs to know where all the manned forklifts are in an area. And if it knows that a manned forklift is coming through the area, what does its behavior need to look like? Because yes, the person on the forklift should be paying attention and looking out for anything, a human, a robot, but sometimes they're not paying attention. So can we develop systems that actually tell the robot that a piece of equipment, manned or unmanned, is coming through an area? It could be a very big, huge issue. And it really does touch on that whole idea of how does a robot and a human interact. So interoperability, even though it is very focused on robot to robot types of communications, there are so many other things tied into that, and robot to human communication is part of that. So when we look at the standards, I will gladly say FedEx is very active in numerous organizations here in the United States. That's A3. We also work with UL. We work with ISO. And being a multinational company, we really want to build solutions that we can deploy anywhere, because that just speeds up this development and helps us as a multinational company to address issues wherever they are in the globe to service our customers. It's not fair that we can't deploy robots to help our customers in certain countries because the standards are different in that country, because that's what they wanted to do and they didn't go with an international standard. So these are things that we very much want to work on with everybody. And just to show, just recently, FedEx was actually the lead sponsor here in the United States at the Autonomous Mobile Conference that A3 put on. So it just shows that we are very much want to be a part of this solution. We want to work with as many folks as we can to address these issues so we can find common ground, so we can actually deploy these types of systems of robots and autonomous vehicles as quickly as possible. And that goes into the regulatory environment. Here in the US, we've actually had to work mainly almost by a state basis for some of these technologies, because there's not a lot of standards for, like Roxo, for sidewalk robots. They are being developed, but we really don't have time. We're ready to go. And there have been some issues in some countries where cities have banned these types of delivery robots because there's questions about safety. Well, it'd be great if we had a safety standard for them that we could show to these government agencies of, hey, there is an international consensus of how these robots are designed and how they work and how they can be safe around humans. But until that happens, we have to almost go here in the United States to 50 different states and sometimes end up with 50 different regulations. And this is not very common in Asia versus here in the United States, but there is still a lot of anti-robot sentiments. So sometimes while we're just trying to focus on the safety aspect with some of these legislators and regulatory bodies, we always get those voices of these robots should not even exist because they're going to be not just unsafe, but they could take jobs from humans. So we have to battle all those kind of things on top of this. So this is where we really want to focus on, can we get international standards that can be applied everywhere and can also address some of these sentiments that are out there. End up with one way we do this through FedEx is we do have a lot of partners in this area, be that the companies that actually are making these robots and we're buying them and deploying them into our systems. But also we work with numerous other types of groups here in the United States. Just an example, I put some of these down, like Mass Robotics in Boston, the Pittsburgh Robotic Association, the ARM Institute that does funding of some of the robot research that's out there. And also we are an active partner in the A3 OSHA NIOSH Alliance here in the United States to help try and streamline these and speed up these processes, because through these partnerships, that's the only way it's going to get done. FedEx cannot be alone in this. We need as many partners as possible. And we always are looking for more partners where we can team up and find those common grounds. And so in conclusion, from a business point of view, we will continue to try and deploy these autonomous assets across our global enterprise, regardless if they're inside our facilities or outside our facilities. We will continue to work with standard organizations like ISO, A3, UL, to encourage these deployments and address the regulatory issue. And finally, we are always open to working with any partner out there that has the same vision of, we want to see more of these robots, but we want to do it safely. We want the public to understand why we're doing these. We want the public to be comfortable with them, because it's the same thing when we deploy them within our operations. We have to train our employees. We have to get their buy-in. And actually, one of the best things we actually do with is our team members actually bring us the use cases that they would actually like to see robotics. And when you get to that point, it is so wonderful because you have that final buy-in. When your own people are asking you to bring in more robots, you have cleared those hurdles. You have built that trust in those robotic systems. And we're doing a really good job on the inside parts of the four walls because our employees see the benefits of the robots. But now, how do we go and explain that to the public? And I think that's the next big challenge for everyone. And I don't care if you're here in the United States, you're in Japan, you're in China, you're in Europe. This is something that is going to take a lot of work and a lot of partnerships to get done. And with that, I again, thank you for having me for this summit.
Okay, thank you. Good presentation. So we have also same issue. Okay, okay. Are there question or comments? Okay, from me. So in Japan, also we have been working for many years to deregulate the use of mobile robots. So, however, only demonstration tests on public road are still permitted. So, there are countries or states that are relatively tolerant in your activity?
I mean, when it comes to our delivery robots?
So you tried many countries, your activity to the in many countries.
Yes.
So I think it's different situations in regulation, about the regulation.
Yes.
So in Japan, I think in Japan is very not as conservative. So
yeah, I mean, and this is where I think if we had an ISO standard that all countries could agree to,
yes.
I think that would really ease it, because we have taken our delivery robots to Dubai. We have tested in Japan our delivery robots. We've tested here in the United States. And it is interesting of some of the feedback we get back from government agencies. But always the top question is like, well, how do we know that you've actually built this robot to some safety standard? And we don't have a safety standard to show them. I like with here in the United States for our robots inside our warehouses, as Dr. Cheng showed, there are those standards that we can show them, those ANSI standards that are for North America. And so when we show those to OSHA, they're like, okay, that's good. Go ahead and deploy, everything good. You did everything. For the delivery robots, we're still trying to get something done. And I think that's holding us back a little bit, because as soon as those ANSI standards came out in the United States, we saw a big boom in robots getting deployed, and everyone could reference those standards. With delivery robots, I think we still have some time. Same thing with autonomous vehicles. We need something that sort of gives us all that clearance, regardless of what country we're in. But I think it's definitely happening, and I know we have some colleagues in Japan that are very much helping us with that.
With advances in AI technology, expectations for automated driving are increasing. Typical target for automated driving technology are automobile in common use. Additionally, HEV technologies for transporting materials within the factory is another example of automatic driving technology. In recent years, there has been a serious shortage of labor in the logistics field, and AGV technology has expanded from factories and distribution warehouses to automated delivery on public road in the town and cities. The key technical object here is to achieve safe and secure interaction between people and mobile moving vehicles. The target persons may be drivers, pedestrians, or workers in factories, depending on the environment. In this session, technologies and applications for safe operation of autonomous mobile robots in the space, where they can coexist with people, as well as safety standards from such operations are introduced. Through these presentations, we hope to confirm the direction of safety technology required in the future. The companies also introduced their wide-ranging safety activities related to mobile vehicles, as well as their future challenges in developing their business.